Hi all, welcome to Go Classes. In this session, we are going to discuss sequential circuit gate PYQs. This is gate PYQs part 1. We are going to discuss all the sequential circuit gate PYQs from gate CS, gate EC, electrical, instrumentation, biomedical. So basically, from all the gate branches based on sequential circuit, all the gate PYQs that are there, all the gate previous year questions we are going to discuss, and this is part 1. So let's start. In the previous lectures, these concepts we have studied. We have seen in the previous lectures introduction to sequential circuit. What is sequential circuit? The difference between combinational circuit and sequential circuit. We have studied all about SR latches, SR latch, S bar, R bar latch. We have solved all the gate CS, gate EC questions PYQs on SR latches. We have studied all about clock signal, its terminology. And also in the previous lectures, we have studied all about flip flops. What is a flip flop? And the four types of flip flops SR, JK, D, T. These flip flops we have studied. All about them we have studied. Also, we have studied age triggering of flip flop. So basically, these are the previous concepts that we have studied in the previous lectures. And based on these concepts that we have studied so far, we are going to solve 100 plus gate PYQs. Okay, many gate PYQs we will solve in this lecture, and because this is part 1, so in the upcoming parts we are going to solve 100 plus gate PYQs based on sequential circuit, only based on these concepts that we have studied in the previous lectures. Okay, so let's start. First, let me share with you some terminology for flip flops. This is very important. We have studied all about flip flop, but what are the some terminologies for flip flops? So let's see. Let's see the first one. Remember, output of a flip flop means the Q output of the flip flop. So, for example, this is the D. This is the D flip flop we have, and you can see this is positive edge triggered because you can see because of this symbol. So this symbol means that this is a positive edge triggered D flip flop, and we have only one input in the D flip flop. We have only one input D, and there are two outputs Q bar. Here, remember this Q. This is the output, or this is, you can say that this is the main output, or by default you can say that this is the output, or you can say main output. And remember this Q complement, this is just a complement of Q. Now if this Q is 0, then Q complement will be 1. If this Q is 1, then Q complement will be 0. Now let's assume that in this D flip flop, let's assume that Q is equal to 0, then automatically Q complement will be equal to 1. So tell me, in this situation, if I ask you what is the output of the flip flop, then what will be the answer? The answer will be Q, or the answer will be Q bar? The answer will be Q. So remember here, for this D flip flop, if I ask you what is the output of this D flip flop, then what answer you will write? You will write answer 0. Okay, remember you will write answer 0, because when I say output of D flip flop, it simply means that Q output of the D flip flop. Okay, so here this simply means, this means Q output of flip flop. Okay, and that is 0. So I can say that output of this flip flop, this is basically 0. Very simple. And remember, the output of flip flop, that is also called state of the flip flop. Correct? So here some extra terminology you can see. I told you that for flip flops we have some equivalent terminology. So here these things are equivalent. I can say that output of flip flop, that is same as Q, and that is same as 0 here in this situation, because Q is 0. So I can also say that state of flip flop, that is 0. I can say that state of flip flop, state of this flip flop, that is 0. I can also say that the bit that is stored in this flip flop, that is 0, because remember flip flop is a single bit storage device. So a bit is stored here, a single bit is stored here. What is that? That is basically 0. So this main output, this is the bit that is stored in this flip flop. So I can say that the bit stored in this flip flop, what is that? What is the bit that is stored in this flip flop? That is also 0. So all these three things are equivalent: output of flip flop, state of flip flop, and bit that is stored in the flip flop. These three things are same. I hope you understood. And when I say output of flip flop, it means Q output I am talking about. Very simple. Now let's see some more equivalent terminology for the flip flops. So on your screen you can see we have all the four type of flip flops: SR, JK, DT. Okay, and you can see this symbol means that these are positive edge triggered. Okay, so very simple. Now here for flip flops there is some equivalent terminology. So let's see that. Set state. Set means Q equal to 1. So remember, whenever I say that flip flop is in set state, it means the Q output that is equal to 1. And Q output is 1, or I can say set state. What it means? It means that bit 1 is stored in this flip flop. So remember, here you can see set state, flip flop is in set state. It means what it means? It means Q output is equal to 1. And what that means? That means bit 1 is stored in the flip flop, because flip flop is a single bit storage device. And what that means? That means flip flop is in state 1. So all these things are equivalent. When I say flip flop is in reset state, then it means that Q output is equal to 0. It means bit 0 is stored in the flip flop, because flip flop is single bit storage device. All these flip flops, they are single bit storage device. So I can say reset state means bit 0 is stored in the flip flop, or I can say that flip flop is in state 0. So basically you can see that state of flip flop, that is same as output of flip flop, and output of flip flop means the Q output of the flip flop, and that simply means bit stored in the flip flop. So you can see output of the flip flop, that means Q output of the flip flop. Okay, so here these three things are same. State of flip flop, that is same as output, that is same as bit stored in the flip flop. I hope it is clear. You can see this example here. You can see we have a D flip flop, and this is positive edge triggered D flip flop. This symbol means that this D flip flop is positive edge triggered, means this will respond to the input at the rising edge of the clock. Okay, now let's assume that D is equal to 1. If the input D is equal to 1, then you can see that at the rising edge of the clock, what will happen? This flip flop will respond to the input. So you can see at the rising edge of the clock, the input D is equal to 1. So what will happen? This output will become 1. Okay, we already know the behavior of the D flip flop, that in the D flip flop, if the input D is equal to 1, then at the rising edge, this 1 will be stored in the D flip flop, and this output will become 1. Okay, so you can see this here, that this 1, this D equal to 1, this input, this will be stored, and it will appear as the output. So you can see what is stored in the D flip flop, that is basically your output. Or I can say what is the output of D flip flop, that is the bit that is stored in the D flip flop. Okay, I hope it is clear. Very simple. So you can see when D is equal to 1, when we provide 1 at the input D, then Q will become 1 at the triggering edge of the clock, because we already know that the D flip flop, this is edge triggered. Here you can see this symbol means positive edge triggered. So at the triggering edge of the clock, this D flip flop will respond to the input, and you can see at the rising edge, this, because of this D equal to 1, this next output, or I can say the next state, will become 1. Okay, very simple. The same thing you can see here. If you provide D equal to 0, then because this is positive edge triggered D flip flop, so at the positive edge, at the rising edge of the clock, this 0 will become your next state, or I can say next output. So you can see this 0 will be stored in this flip flop, and it will appear as the output. Okay, very simple. So whatever we have seen, that is basically written here. You can read it. Now let's study circuits containing flip flops. We have studied all about flip flops. We have studied. Now let's see what are circuits containing flip flops. This is very simple. Any circuit, any digital circuit containing flip flops is a sequential circuit. Okay, any digital circuit containing at least one flip flop is basically sequential circuit. You can see, for example, this is a sequential circuit. Here we have two D flip flops. Okay, in this circuit we have D flip flop, D flip flop. There are two D flip flops. You can see in this sequential circuit, because this contains flip-flops. So this is sequential circuit, and you can see this contains one T flip-flop, one D flip-flop. Look at this circuit. This circuit contains four flip-flops. Four JK flip-flops are there. So this is also sequential circuit. And you can see, look at this circuit. Here we have one JK flip-flop, one D flip-flop, one T flip-flop. So this circuit is also your sequential circuit. So any circuit containing flip-flops, that is basically sequential circuit. Remember, latches are also sequential circuit. So I am not saying that sequential circuit means it must contain flip-flop. No. You know, SR latch, S bar, R bar latch, latches are also sequential component, or I can say sequential element. So they are also sequential circuit. I'm simply saying that if you have a digital circuit which contains at least one flip-flop, then that is basically sequential circuit. Okay, very simple. Now let's see a very important point, that is, what is the state of a sequential circuit? We already know what is the state of a flip-flop. For a single flip-flop, what is the state of a flip-flop? That is the bit stored in it, or I can say that is the output of the flip-flop, the Q output. But what is the state of sequential circuit? For example, if you consider this sequential circuit, here we have three flip-flop, one JK, one D, one T. We have three flip-flops. So if I ask you what is the state of this circuit, then what will be the answer? Very simple question. So remember, state of a sequential circuit, that is basically the output combination of flip-flops. Here you can see, for this single flip-flop, you know what is the state. State means the output of the flip-flop, that is the state of the flip-flop. So what is the state of this entire sequential circuit, this entire circuit which contains three flip-flop, what is the state of it? So that will be the combination of states of the flip-flops. So I can say Q2, Q1, Q0. This combination Q2, Q1, 0, Q2, Q1, Q0, this 3-bit combination, this is the state of this entire circuit. Okay, or I can say the output combination of the combination of output of flip-flops, that is the state of sequential circuit. Okay, so you can read this here. State of a sequential circuit, that is flip-flop output combination. Okay, in a sequential circuit you can have one or more flip-flops will be there. So you can see the flip-flop output combination, that is the state of sequential circuit. Okay, so you can see in this sequential circuit, the flip-flop output combination Q2, Q1, Q0, this flip-flop output combination, this 3-bit combination, this is basically state of this sequential circuit. You can see in this sequential circuit, we have two flip-flop, two D flip-flop are there. So the combination of flip-flop output, that is basically state of this sequential circuit. And you can see for this sequential circuit, the flip-flop output combination, that is the state. So here every state has 2 bits, because this 2-bit combination Q1, Q0, this combination flip-flop output combination, that is the state of this sequential circuit. And in this sequential circuit, can you tell me the state will have how many bits? The state of this circuit will have how many bits? Total 4 bits, because we have total 4 flip-flops. So the flip-flop output combination, basically this 4-bit combination, this is the state of this sequential circuit. I hope it is clear. With example, it will become more clear, but the point is, state of a sequential circuit, that is flip-flop output combination. Now let's see some examples. Consider this question. A circuit with flip-flops, circuit containing flip-flops is given to you. So this is a sequential circuit, you can see. What is the state of the above circuit? Simple question. For this sequential circuit, what is the state of this circuit? And here it is given that Q1 is the MSB and Q4 is the LSB. You can see basically this flip-flop, this is the most significant flip-flop, or I can say this is in the most significant position, this is in the least significant position. You can see Q1 is the MSB, this Q1 is the MSB, Q4 is the LSB. So what is the state of this sequential circuit? The answer is what? Very simple. State of a sequential circuit, that is the flip-flop output combination. So here you can see the state will be what? You can see this flip-flop output combination, this. So here you can see what will be the state. State of above circuit, that will be flip-flop output combination. So that is, you can see Q1, Q2, Q3, Q4. This is the flip-flop output combination. Q1 is the output of this D flip-flop, Q2 is the output of this D flip-flop, and so on. So flip-flop output combination, that is the state of this sequential circuit. So you can see that will be 1 0 0 0. So remember here the state is what? That is basically 1 0 0 0, means this 4-bit combination, this is the state. Okay, this is the state. This is the current state, I can say. Present state. Okay, I hope you understood. Very simple. Tell me the answer for this question. The same circuit as the previous question, but now you can see Q4 is MSB and Q1 is LSB. Means Q4, this is the MSB. Q1, this is the LSB. So what is the state of above circuit? State of sequential circuit means flip-flop output combination. So you can see this flip-flop output combination, output of flip-flops, these are Q4, Q3, Q2, Q1. These are the flip-flop outputs. So you can see Q4 is MSB. So I will write like this: Q4, Q3, Q2, Q1. Because here you can see that Q4 is MSB. Okay. So you can see Q4 is 0, Q3 is 0, Q2 is 0, Q1 is 1. So now the state is basically 0 0 0 1. Okay, very simple. In the previous question, you can see Q1 was MSB, Q4 was LSB. So we are writing the state Q1, Q2, Q3, Q4 because Q1 is MSB. And you can see in this question, you can see Q4 is MSB. So we are writing the state of the circuit. State of the circuit, we are writing Q4, Q3, Q2, Q1. Simple. Tell me the answer for this question. What is the state of the given sequential circuit? This is a circuit containing flip-flop. So this is sequential circuit. The state of a sequential circuit, that is flip-flop output combination. What is the state of above circuit? Assume Q1 is MSB, Q4 is LSB. So the state of above circuit, that is flip-flop output combination. The output of flip-flops, that is basically Q1, Q2, Q3, Q4. And you can see that is Q1 is 1, Q2 is 0, Q3 is 1, Q4 is 0. So here the state is basically 1 0 1 0. This is the state of this sequential circuit. I hope you understood. Simple. Now remember one thing, that I told you that output of a flip-flop, that means that is the bit stored in that flip-flop. So can I say that, look at this D flip-flop, the output of this D flip-flop is basically 1. It means that this bit 1, this is stored in this D flip-flop. This bit 0, this is stored in this D flip-flop. This bit 1 is stored in this D flip-flop, and this bit 0, this is stored in this D flip-flop. So you can see that this 1010, this is basically the content stored in this circuit. Can I say this is basically the content stored? This is the content stored in the given circuit. Because remember, every flip-flop is a single bit storage device. Single bit, single bit, single bit, single bit, like that. So you have total 4 flip-flop. It means a 4-bit number is stored here. Yes or no? A 4-bit content is stored in this circuit. Each flip-flop is storing single bit. Total we have 4 flip-flops. So a 4-bit content is stored in this circuit. And that 4-bit content that is stored in this circuit, that is 1010. So you can see content stored in this circuit, that is what? That is 1010. Okay, I can say that is 1010. This is the content that is stored in this circuit. I hope it is clear. So I can say this is the content stored in this circuit. I can also say this is the state of this circuit. I can also say this is the output of this circuit basically. Okay, I hope it is clear. Okay, so simple. So you can read this here. State of a sequential circuit, that is the flip-flop output combination. And I told you that flip-flop output, that is the bit that is stored in the flip-flop. So I can say that state of a sequential circuit, that is the content stored in the circuit. Yes or no? So you can see the state of a sequential circuit, this is the current values, the current content that is stored in its flip-flops. State of a sequential circuit, that is the current values stored in its flip-flops. Okay, or I can simply say that the state of a sequential circuit, this is the content stored in it. Content stored in its flip-flops. Simple. So here, one example I have given to you. For example, if a sequential circuit has three flip-flops, total three flip-flops we have in the circuit, and let's assume that the output of flip-flop 1, that is 0, and this flip-flop 1, this is the MSB. The output of flip-flop 2, that is 1. The output of flip-flop 3, that is 1. Here, remember, output of flip-flop 2 is 1. It simply means that this bit 1 is stored in the flip-flop 2, bit 0 is stored in the flip-flop 1, bit 1 is stored in the flip-flop 3. So what is the state of this circuit? The state of circuit, that will be 0 1 1, because this flip-flop 1, this is the MSB. Okay, I can say that this is the circuit state, or I can say that this is the content stored in the circuit. In the circuit. Simple. I hope you understood. Now you can see, if we have a circuit containing only one flip-flop, in our circuit only one flip-flop is there, then how many states are possible? Only two states are possible, either 0 or 1, because we have only one flip-flop. A flip-flop is single bit storage device, so either bit 0 will be stored or bit 1 will be stored. So I can say that circuit containing one flip-flop, it will have two states possible, either 0 or 1. Circuit containing two flip-flop, then four states are possible, because what is the state of sequential circuit? State of circuit means flip-flop output combination. So we have two flip-flop, so you can see each state will have two bits. Each state is basically combination of two bits. So you can see that four states are possible: 0 0, 0 1, 1 0, 1 1. These four states are possible. Circuit containing three flip-flops, then 8 states will be possible, because we have three flip-flops. Each flip-flop can store either 0 or 1. So total 8 states are possible. Each state contains 3 bits. Okay, because we have three flip-flops, so here you can easily see what will be the states possible. The states possible, these will be 0 0 0, 0 0 1, 0 1 0, 0 1 1. Okay, and so on, you know. So these are the 8 states that are possible, because we have three flip-flops. Each flip-flop stores single bit. So you can see the state of the circuit, that will be a combination of 3 bits. And if you have circuit containing 4 flip-flop, then total 16 states will be possible. If you have circuit containing n flip-flop, then 2 power n states will be possible. Okay, very simple. I hope you understood. Let's study the next topic, that is synchronous sequential circuit. What is the meaning of synchronous circuit, and what is the meaning of asynchronous circuit? It's very easy. Synchronous sequential circuit means, in this type of sequential circuit, all the flip-flops, they are operated by the same clock. Okay, the name itself is telling you synchronous. So synchronous sequential circuit means all flip-flops, they are operated by the same common clock signal. Asynchronous sequential circuit means that flip-flops are not operated by common clock signal, means different flip-flops, they are operated by different signals. Okay, you can see in the synchronous sequential circuit, all the flip-flops are operated by the single, or I can say by the common clock signal. But in the asynchronous sequential circuit, flip-flops are operated by different clock signals. Okay, they don't have common clock signal basically. So you can see, in short, synchronous means common clock for all flip-flop. Asynchronous means no common clock, means all the flip-flops, they have different clock. Okay, now notice one more thing, that in the synchronous sequential circuit, all the flip-flops are operated by the same clock signal. And let's assume that all the flip-flops, they are, let's assume, positive age triggered. Let's assume we have 3 flip-flop and all of them are positive age triggered. Then you can see that in the, because all these flip-flops, they are operated by the same clock signal, so at the same time all these flip-flops will respond to the inputs. So you can notice that in the synchronous circuit, in the synchronous sequential circuit, you can see all the flip-flops, they will change output at the same time. because all the flip-flops are operated by the same clock signal. So you can see in the synchronous sequential circuit, all the sequential element means flip-flop. All the flip-flops will change their outputs at the same time, means they will respond to the inputs at the same time. But in the asynchronous, they will not respond to the inputs at the same time. Okay, because they are not operated by the common clock signal in the asynchronous. Don't worry about asynchronous right now. In future, we will study. In this lecture, and also for the next 100 plus gate PYQs, we are going to focus on the synchronous sequential circuit. Most of the gate exam questions, most of the gate PYQs are based on synchronous circuit. Okay, so first we are going to discuss all about synchronous sequential circuit. All the gate PYQs we will solve based on synchronous sequential circuit. Then we will go to asynchronous circuit. Okay, so for a moment, or I can say for right now, don't worry about asynchronous. Just focus on synchronous, and these are very easy to understand. So the definition we have seen: synchronous sequential circuit means all the flip flops are operated by common clock signal, by the same clock signal. You can see this example. In this gate 1994 question, this circuit is given to you. This is a circuit containing flip flops. So this is a sequential circuit. Now you can see, notice that we have three flip flops. We have JK flip flop, D flip flop, T flip flop. There are three flip flops are there, and you can see they are operated by the same common clock signal. You can notice this common clock signal is basically the input for all these flip flops, or I can say that all these flip flops, they are basically operated by the common clock signal. Okay, yes or no? You can notice this common clock signal is basically going to all these three flip flops. Okay, you can see, and all of them, you can see they are basically positive edge triggered flip flops. So what is this circuit? You can see in this circuit, in this sequential circuit, all the flip flops, they are operated by the same clock signal. So this is basically your synchronous. This is synchronous sequential circuit. Okay, you can notice that this common clock signal, this is going as input to all these three flip flops. Okay, very simple. Consider this gate 2010 question and tell me this circuit that is given to you containing two T flip flops, this is a synchronous circuit or asynchronous circuit. Here you can notice this T flip flop is operated by this clock signal, but notice for this T flip flop, the clock signal is basically the output of this T flip flop. Notice for this T flip flop, the clock signal is output of this T flip flop, means this T flip flop and this T flip flop, they don't have common clock signal. For this T flip flop, this is the clock signal, and for this T flip flop, this Q0 is the clock signal. Are you getting my point? So you can see that here you can see for this T flip flop, the clock signal is clock. Yes or no? Here you can see that operated by clock, or I can say that clock signal is clock. Okay, and notice for this T flip flop, you can see that the clock signal is basically Q0. Okay, I hope you understood. So you can notice here that this output of this T flip flop, that is the clock for this next T flip flop. Are you getting my point? Notice this. Okay, so here you can see this circuit, this is asynchronous circuit. This is asynchronous sequential circuit. I hope it is clear. In this gate 2005 question, we have a circuit containing flip flops. This is synchronous circuit or asynchronous circuit. You can see this common clock signal is input to all the flip flops, or I can say all the flip flops. We have two D flip flops here, and both of them are operated by the same clock signal. Yes or no? So this is synchronous. This is synchronous circuit. Simple. And tell me the answer for this circuit. This circuit in GATE 2014 question, this is synchronous circuit or asynchronous circuit. You can see that common clock signal. Notice C. Basically, they want to represent that a common clock signal C is the input for all these flip flops, or I can say all these flip flops, they are operated by the common clock signal C. So notice here C means basically they want to say in this diagram, they want to say that all the flip flops, they are operated by the common clock signal. Actually, they have written also that this is a synchronous sequence circuit. The reason is simple, because all the flip flops, they are operated by common clock signal. Okay, all the flip flops, they are operated by the common clock signal C. So this is basically synchronous sequence circuit. I hope you understood. So the definition we wanted to see what is synchronous circuit, synchronous sequence circuit, and asynchronous sequence circuit. Now remember, in this lecture, we will discuss all about synchronous sequential circuit. And then we will solve 100 plus gate PYQs. Most of the gate PYQs in all the gate branches, they are based on synchronous sequence circuit. So first we will see all the gate PYQs based on synchronous circuits. And then after that, we will see asynchronous circuits also. Okay. Now let's study analysis of synchronous sequence circuit. So now, first we are going to study all about synchronous sequence circuit, how to do the analysis. If a question comes based on synchronous circuit, synchronous sequence circuit, then how to solve it. Okay, so first we will see all the steps, then we will see all the gate PYQs based on synchronous sequence circuit. And then after that, after solving almost all the gate PYQs based on synchronous circuits, then we will study analysis of asynchronous circuits also. So let's study analysis of synchronous sequence circuit. First, let me tell you that in the synchronous sequence circuit, when we do analysis, then what are the components we should consider for the analysis? Components that we need to consider in the analysis of synchronous sequence circuit. You can see on your screen, this is a synchronous sequence circuit. What is the reason? Because you can see we have two D flip flop. There are total 2 flip flop, and they are operated by the common clock signal. Can you notice? Both these D flip flop, they are operated by common clock signal. You can see. So this is a synchronous sequence circuit. Now, what are the components that we need to consider in the analysis of synchronous circuit? Very simple. Total basically 4 components we need to consider here. Inputs, outputs. In the inputs, flip-flop input and external input. Notice here in this circuit, notice that we have external input. This X here, this X, this is the external input. Okay, this X is the external input here. And you can see these D flip-flop, they have inputs also, this D and this D, these inputs. Correct? So these are flip-flop inputs. So notice, when I say inputs, then there are 2 type of inputs. One is external inputs, which are optional, means they may or may not be there. In some synchronous circuit, these external inputs will be present. In some synchronous circuit, these external inputs will not be present. So that is the reason I have written optional here. So remember, in the synchronous circuit, there are 2 type of inputs here, flip-flop inputs and external inputs. So here you can see this, look at this X, this is the external input. And this D, because we have 2 D flip-flops, so their input we have, these are called flip-flop inputs. Okay, so you can see flip-flop inputs, let me write in pink. In pink you can see. Okay, and now let's see outputs. So you can see there are flip-flop outputs, of course. You can see here we have 2 D flip-flops, so their output, you can see this flip-flop, this is a flip-flop output. This is a flip-flop output. So you can see flip-flop outputs. And remember, the flip-flop output, they will represent the present state of the circuit. I told you, in any sequence circuit, what the state of the circuit? State of the circuit means flip-flop output combination. So you can see what are the flip-flop outputs, this A, B. For example, if they are 0, 1, then what is the state of this circuit? What is the present state of this circuit? That will be 0, 1. If A is MSB, and B is LSB, then the present state of this circuit, that will be 0 1. Correct? So you can see that flip-flop outputs, these are basically the present state of the circuit. Okay, so flip-flop outputs, this I am writing in green. You can see in green color, you can see in this diagram. Okay, and at last you can see we can have external outputs also, but they are optional. So some synchronous circuit will have external output, some will not have. Here you can notice in this entire circuit, you can notice this Y, this is a external output. This is not output of flip-flop. Notice this A, B, these are output of flip-flop. But you can see this Y, this is external output. Okay, so you can see this external output. Here you can see this Y in orange. I hope you understood. So remember, when we do the analysis of synchronous circuit, then these are the components that we need to consider. External input, external output, they are optional. They may be there, they may not be there. Most of the time they will not be there, but they can be there. We will discuss all, don't worry. All the situations, all the possibilities we will discuss, all the gate PYQs we will discuss, so don't worry. Next, you can see from the flip-flop point of view, from this flip-flop point of view, we have inputs and outputs. The output of flip-flop, that will represent the present state of the circuit. So if I ask you what is the present state of the circuit, then don't worry about the external output. State of the circuit simply means flip-flop output combination. Okay, I hope it is clear. Simple. Now let's see. This actually we have already seen that in the sequence circuit, the next state, that is a function of present state and present inputs. Correct? The same thing happens in the synchronous circuit also. In the synchronous sequence circuit also, the output and the next state, output means the external output, which may or may not be there. I told you external output, these are optional. This Y, this is a external output, this may or may not be there. Now you can see the next state, this is basically a function of present inputs and present state. So this actually we have already seen in our previous lectures also. I told you that in the sequence circuit, basically the next state, I can say q next, the next state, I can also write it qn, I can also write it q plus, I can also write it q t plus 1, means state at time t plus 1. Okay, these are different ways to write this next state. Okay, so these all of them, they represent basically next state. Now remember, this next state, remember, this is basically a function of, this depends on two things. This is a function of present inputs and present state. Okay, present state means q, and present inputs. In when I say inputs, then there are two type of inputs. I told you, flip-flop inputs and external inputs. Okay, and external inputs, they are optional. Here you can see this x, this is external input, and these are the flip-flop inputs. Okay, the overall the point is that in the sequential circuit, in the synchronous circuit also, the next state is a function of present inputs and present state. I hope it is clear. Okay, and remember all these are notations for next state. These are notations for next state. And when I say state, it automatically means output. Next state means next output. Okay, so you can see, so we can specify the next state as a function of present state and inputs. Okay, very simple. Now let's see the steps. I told you in the gate exam, if they give you any question based on synchronous circuit, a synchronous sequence circuit is given to you, then how to do the analysis? We need to see the steps for the analysis of synchronous sequence circuit. So let me tell you all the steps. I will explain one by one, and then at the end we will see all the steps in a single page. Right now you can see this is step number 1. Then we will see step number 2, step number 3, like that. and then at the end we will see the complete conclusion of the steps. Okay, so you can see in the analysis of synchronous sequential circuit, the step number 1, that is write flip flop input equations. Flip flop input equation, remember, means for example here we have two flip flops, so we will write their input equation. Their input equation means this d0 d1, these are the flip flop inputs, correct? D0 d1, these are the flip flop inputs. We will write their equation. So you can see write flip flop input equation means you basically determine the input of each flip flop, and the flip flop input, remember, that will be derived from external input and the present state. You will see, don't worry. Here you can notice this example I have given to you. Here, let's write the flip flop input equation. What are the flip flop inputs? These are D0, D1. So first of all, you notice what are the flip flop inputs. Flip flop inputs are D0, D1. These are the flip flop inputs, correct? Okay, we have two flip flop and their inputs are D0, D1. Now we need to write their equation. We need to represent the D0, we need to represent the D1. Means what is the equation for D0, what is the equation for D1? Let's see. Now you can notice this D0 is same as X. Can you notice this X? This is D0, this X is D0, means this D0 is same as X, nothing else. This X is D0. So D0 is equal to X. What is D1? You can notice D1 is basically AND of X and Q0 bar. Notice the D1. D1 is basically this Q0 bar. For in this AND gate, one input is Q0 bar, another input is X. So you can see this is X and Q0 bar. So that's it. This is the step number 1. Very simple step, right? That you write the flip flop input equations. Here you can see we have two flip flop and their inputs are D0, D1. We are writing their equation. And you can notice one thing, that flip flop inputs are derived from external inputs and present state. I told you that these flip flop outputs, they will represent the present state. Okay, for example, let's assume that Q0 is 1 and Q1 is 0. And let's assume Q0 is MSB. Then you can see this Q0, Q1, if they are 1, 0, then this 1, 0, this will be your present state of the circuit. Okay, very simple. Anyway, the point is that you write the flip flop input equation. That's it. Very simple point. Let's consider this example. Remember, we are just seeing the examples of how to write the flip flop input equations. So we are at the step 1 right now. Then I will tell you what is the step 2. But right now, let's understand the step 1, that we are writing the flip flop input equations. Let's consider this circuit. In this circuit, we have JK flip flop, D flip flop, T flip flop, 3 flip flops we have. Now let's write their input equation. So when I say input equation, flip flop input equation means we need to write the equation for J, equation for K, equation for D, equation for T. Correct? Yes or no? So here, first of all, you realize what are the flip flops. You can see what are the flip flops used. You can see one JK flip flop used, one D flip flop used, and one T flip flop used. Okay. Now, what are the flip flop inputs? What are the flip flop inputs? The flip flop inputs, you can see J, K, D, T. These are the flip flop inputs. Now let's write their equation. We need to write the flip flop input equation. So let's write what is the J. What is the equation for J? You can see this is J. And notice J is equal to what? Notice from where it is coming. This signal is coming from Q0 bar. So notice this Q0 bar is your J. So J is equal to Q0 bar. Simple. What is K? What is K? K is fixed. K is equal to 1. Yes or no? K is fixed. K is equal to 1. We are writing the flip flop input equations. So let's see. What is D? You can see D is equal to Q2. This Q2 is the D. So you can see this Q2, D equal to Q2. And what is T? That is Q1. You can notice this Q1, this is basically going to T. So you can see this T is equal to Q1. That's it. So this is the step number 1, writing flip-flop input equations. This step is so easy. Do you agree with me? That whatever circuit is given to you, whatever synchronous sequential circuit is given to you, then you can write the flip-flop input equations. Notice one thing. This is a synchronous circuit because all the flip-flops, they are operated by the common clock. Yes or no? The common clock, you can see this common clock is the input to all the flip flops. So very simple. Now tell me, let's write the flip flop input equations. So here you can see the flip flop inputs. These are T2 and T1. What is T2? T2 is XNOR here. XNOR of, you can see T2, this is XNOR of Q1, Q2. So it's basically Q1 XNOR Q2. Okay, correct. Simple. Okay, very easy. So this T2, this is basically Q1 XNOR Q2. And what is T1? T1 is X, that's it. Okay, so these are the flip flop input equations. So this is the step number one. I hope it is clear. Now let's see step number two. What is the step number two? Step two is draw the state table. Now remember the step number one, that was writing the flip flop input equations. Then the step number two, this is draw state table. When I draw the state table, then basically what you need to do, it's very simple. Basically input output, basically you need to draw the truth table. It's basically like you need to draw the truth table, state table, or I can say that you basically need to draw the truth table. So here what will happen, you will write the present state, because remember present state is an input. Do you agree with me? Notice one thing, that from the flip flop point of view, from the sequential circuit point of view, this next state, this q next, this is function of present inputs and present state. Now notice, this is what we need to find, the next state we need to find. So this is basically the output. Okay, and notice these are basically the inputs. Correct? Means if you need to find the next state, then that will depend on I comma q. What is q? This is the present state. This is the present output or present state. This is the present state or present output. But remember, this is input. If you need to find the next output or next state, yes or no? So you can see this qn, this is your next output or next state. So if you need to find it, then remember this present state will be one of the inputs, and this I, this is your present input. Okay, simple. So I hope it is clear. So you can see we are going to draw the state table. State table simply means truth table. It will consist present state. Okay, present state column will be there, column for present state. Then if you have external input, then that will be there. But I told you external input, that is optional, so it may not be there. But if you have external input, then that will be there. Basically you can see present state and inputs. This will be your columns, followed by next state comma output, because this is what we need to find. Yes or no? So you can see, look at this statement from the viewpoint of truth table. From the viewpoint of state table or truth table, you can see the inputs are basically input comma present state, and the outputs are output comma next state. Okay, so here you can see with examples it will become more and more clear, but the point is very simple, that inputs, outputs. Okay, this type of table you need to create. Inputs, outputs, means if these are the inputs, then what will be the output? If these are the inputs, then what will be the next state? Very simple. So you can see, draw the state table or truth table. It will consist three to four sections. You can see present state, external input if any, next state, output if any. And one more thing here from my side, that add columns for flip flop inputs also in between, means before the next state. See what I'm saying here, you can see here at this point, basically before the next state, what you do, add columns for flip flop inputs also before the next state column, for convenience and ease. Okay, we will see, it will be very useful to you, that what you do, before the next state column you add a column for flip flop input also. Okay, so overall the point is that you make columns for all the inputs. You make column for present state, external input, flip-flop inputs. So you make columns for all the inputs, and then followed by you make columns for the output and next state. Okay, so this type of state table you create. With example, it will become more and more clear, and it will become very trivial thing. You will become expert in this. It's right now it might be feeling, because we are not taking examples, so that is the reason maybe it you are not able to understand, but don't worry, this will become very easy. Basically, we are just creating truth table, nothing else. Okay, so this is the step number 2, that you create the truth table, or I can say state table. Then step number 3, if required, depending on the question, if required, then construct the state diagram also. Sometimes the question will ask you to create the state diagram. Okay, so that we will do if required, means if the question is asking to create the state diagram, then we will create the state diagram. What is the meaning of a state diagram? Means how we are going from one state to another state. Means if you are in this state, then what will be the next state? If you are in this state, then what will be the next state, like that. So you can see, construct the state diagram if needed. We have already seen in the previous lectures when we were discussing flip-flops, what is state diagram. This is simply a graphical representation of state table. Means from which state you are going to which state. Very simple. Circle, every in a circle we will write a state, and then from one state you are going to another state, so we will write the transitions. Okay, again it will become more and more clear when we will take example. The point is, if required, depending on the question, construct state diagram also. That's it. So all the steps are over. Not too many steps. Do you agree with me? Just 3 steps. And even then also you can see this third step is basically depending on the question. Only 2 steps are there. The first step is flip-flop input equations you write. Okay, for all the flip-flop, for their inputs, you write the equations. You can see, determine the input equation for each flip-flop. Then you draw the truth table. And when you draw the truth table, then I told you that there will be columns. First, you will have columns for present state and inputs. When I say input, then external input as well as flip-flop inputs. Correct? So you can see, you have columns for present state and inputs, and then followed by, then there will be columns for next state and output. Basically, from here, this is what we will find. Okay, very simple. Now let's see a note here. Flip-flop output represents the present state of the circuit. This we already know. What is the present state of a sequential circuit? That is the flip-flop output combination. So this note we already know, that flip-flop output combination, that is the present state of the circuit. Let's see the next. Flip-flop input will help you find the next state of the circuit. If you want to find the next state of the circuit, who will help you? The flip-flop inputs will help you, and also the present state is going to help you, because you know that next state, that is a function of inputs and present state. So you can see, flip-flop inputs, they will help you determine the next state, but here remember, present state will also help you. Basically, the next state depends on present inputs of the flip-flop, external inputs also if there are any, and the present state of the circuit. Okay, very simple. Now this is the sequence. Basically, you can see, external inputs if you have, plus present state. Basically, using these we will determine the flip-flop inputs, and once we have the flip-flop inputs, then we will determine the next state. Okay, see, this is the sequence. This sequence will become more and more clear when we take the examples, but the sequence is actually very simple, that you have external inputs are there and the present state is there. This is what you have. Now, with the help of external input and present state, you find the flip-flop inputs. Once you have the flip-flop inputs, then you find the next state. Okay, this will be the sequence, but it will become more and more clear when we take examples. So let's start now. Now we are going to take a lot of examples. Okay, this complete steps, are they clear? Very simple. The step number 1, you write the flip-flop input equations. For each flip-flop, you write their input equation. Then you draw the state table. State table, basically, it has present state plus inputs followed by next state. Then if required, depending on the question, you draw the state diagram. That's it. Okay, so now let's solve a lot of questions and also get PYQs. Now let's see some practice questions on synchronous sequence circuits. Let's solve this question. Analyze the given synchronous sequence circuit. Find out the next state if the initial state is Q2, Q1, Q0 equal to 0, 0, 0. First of all, you can notice this is a synchronous sequential circuit. How do I know? Because you can see all the flip flops, they are operated by the common clock. You can see the common clock is the input. Common clock is the input to all these flip flops, correct? So you can see this circuit, this is a synchronous sequential circuit. Now you can see the question is asking the next state, and the initial state is Q2, Q1, Q0 equal to 0, 0, 0. Notice one thing. What this actually telling you? Here it is telling you that Q2 is the MSB. Notice we have three flip flops. So we have three outputs Q1, Q2, Q0, Q1, Q2. Which of them is MSB? How to know? Means which flip flop is at the MSB position? Q0, Q1, Q2, which of them is MSB? How do I know? That is given here. You can see what this simply means. What this means? This means that Q0, this is LSB, and Q2, this is MSB. So you can see Q2 is MSB and Q0 is LSB. Okay, this is the one thing that you need to know. This is given to you here. Okay, now let's see. So the current state, that is 0, 0, 0. What that means? State of a circuit, that means flip flop output combination, yes or no? So notice flip flop output combination is 0, 0, 0. Q2 is 0. You can see this is basically Q2. Okay, you can see here Q2. So I can say that this is basically Q2, means this is 0, and this is Q1, and this is Q0. And you can see Q1 is also 0 and Q0 is also 0. So remember, state of a circuit, state of a sequence circuit, that means flip flop output combination. So this is the current situation. I hope you understood. Now we need to find the next state. And you can see all these flip flop, these are positive as triggered. Basically the question is asking that the situation is like this. This is the clock. Okay, this is the clock. And the situation is like this, that at this point, let's assume at this point, you can see this Q2, Q1, Q0, these are 0, 0, 0. And basically we need to find the next state. Next state means on this rising edge, this flip flop will respond to the input. Do you agree? Okay, we already know that on the rising edge, because these are positive edge triggered flip flop, all these flip flop are positive edge triggered. So I can say on this rising edge, these flip flops will respond to the input. So basically, we need to find that after this rising edge, what will be the state? Okay, or I can say that here we need to find the state Q2, Q1, Q0. What that will be? This is what we need to find. I hope this point is clear. Very simple, right? You can see the initial state is given to you, that is 0, 0, 0. And the next state question is asking, but all these flip flop, these are positive edge triggered. So you can see before the clock, before the positive edge of the clock, this is the state 0, 0, 0. At this positive edge, these flip flop will respond to the input. So I can say that we need to find the next state. Means after this rising edge, what will be the next state? This is what we need to find. I hope it is clear. Now I told you that when you have synchronous sequence circuit, then how to do the analysis? Very simple. You will write the flip flop input equations, then you will draw the state table. How to draw the state table? Very simple. Present state comma inputs followed by next state. Okay, so let's see here. In this example, first, what is the step number 1? You will write the flip flop input equations. Okay, so tell me what will be the flip flop input equations? Flip flop input equations we need to write, because this was the step number 1. Okay, so tell me what are the flip flop input equations here? Here you can see that we have 3 flip flops. Okay, and let's call it Q0, this Q1, this is Q2, because you know this is Q2. So let me call this T0, let me call this T1, let me call this T2. These T flip flop, I'm calling them T0, T1, T2. So you can see what is T0, that is fixed, that is 1. Okay, flip flop input equations I'm writing. What is T1? You can see T1 is same as Q0. T1 is same as Q0. And you can see what is T2? T2 is same as Q1. Okay, that's it. So this is the step number one. Now, what is the step number two? We need to find the state table. State table we need to find. Okay, now let's see how to find the state table. State table is very simple. Input followed by output. So what are the inputs? The present state. See, in the state table, what you are going to do? The present state. Here you can see we have three flip-flop. So the state will be basically a combination of three bits. Okay, you can see this Q2, Q1, Q0. This is your present state. Yes or no? So remember Q2, Q1, Q0. This is the present state. We have this is the present state. You already know what is the state of the sequential circuit. State of circuit means the flip-flop output combination. Flip-flop output combination. This is the present state. Okay, and also what are the inputs? Means flip-flop inputs. So here you can see the flip-flop inputs. These are T2, T1, T0. These are the flip-flop inputs. These are the flip-flop inputs. Okay, and then followed by what is the next state? Means Q2 next, Q1 next, Q0 next. Okay, so basically this is the state table. This is called state table, and it's very simple. Remember, you can notice here present state, flip-flop inputs, followed by next state. Okay, this is next state. This is next state. So let's solve it now. Now you can see the question is saying that the present state is 0, 0, 0. Present state, this is 0, 0, 0. So tell me, what will be T1, T2, and T0? You already know that T0 is 1. Okay, so actually let me write here. You already know that. Here, let me write that. You already know that T0, that is 1. T0 is 1. And T1, T1 is Q0. And T2, that is Q1. Okay, T2, that is Q1. That's it. So now let's see. Tell me, the present state is given to you, that is 0, 0, 0. So what will be flip-flop inputs? T2, T1, T0. T0 is fixed, that is 1. T1, that is Q0. T1, T1 is equal to Q0. Q0 is 0. And you can see T2 is equal to Q1. T2 is equal to Q1. So that is 0. Okay, very simple. So far it is very easy. This is given to you. Present state is given to you. These are the flip-flop input equations. So we can write the flip-flop. We can find the flip-flop inputs. Okay, now let's find the next state. So you can see these are basically T flip-flops. You remember the behavior of the T flip-flop. In a T flip-flop, if the input is 1, if T equal to 1, then that is the toggle combination. Means the next state will be complement of the present state. And if T is equal to 0, then that is hold or latch combination, means the next state will be same as the present state. Yes or no? So you know the behavior of the T flip-flops. Just use that. Notice one thing, that this Q2, notice this Q2, this is the output of this T flip-flop. So this Q2 next, that will depend only on Q2 and T2. Yes or no? So notice this Q2 next, this will depend only on Q2 and T2. Means from this Q2 and T2, you can find this Q2 next. Okay, so you can find this Q2 next. Tell me what will be Q2 next? T2 is 0. And in the T flip-flop, if T equal to 0, if the input is equal to 0, then the state will not change. The next state, that will be same as the current state, the present state. So you can see next state will be same as the present state. It means it will be 0. So did you notice that from these two, this is what we are finding. Now let's see, what about Q1 plus? You can see this Q1, this is the output of this T flip-flop. So what is the Q1 next? That will depend on T1, Q1. Okay, yes or no? This input T1 and this Q1, this present state Q1, these will decide what will be the next state of this T flip-flop. So notice, for this T flip-flop, you can see this Q1 and this T1, they will decide what will be Q1 next. Tell me, if T1 equal to 0 in a T flip flop, if the input is 0, then the state will not change. So you can see the next state that will be same as the present state. So you can see it will be 0. Simple. And what about this Q0 next? You can see Q0 is the output of this T flip flop. So what will be Q0 next? That will be decided by this T0 and Q0. Yes or no? The next state, the next output of this T flip flop, this will be decided by this input T0 and this present state Q0. So very simple point here, that what will be this Q0 next? T0, that is 1. In a T flip flop, if the input is 1, then the next state, that will be complement of the present state. Yes or no? So you can see this T0 is 1. So the next state Q0 plus this next state, this will be complement of the present state. The present state is Q0 0. So you can see I will write here 1. Okay, I hope it is clear. So you can see that this Q0 and this T0, they will determine the Q0 next. Okay, that's it. So finally the answer is that if this is your present state 0 0 0, then the next state will be 0 0 1. I hope it is clear. Tell me. So you can see the final answer. The final answer is 0 0 1. For this question, the answer is 0 0 1. What the question was asking? The question was asking that find out the next state. Okay, find out the next state. So that answer we have seen, that is 0 0 1. Okay, I hope it is clear. Let me know. Simple. Now let's see another method also. One method we have seen. Now let's see another method also. Remember, this is a synchronous sequence circuit. And I told you that in the synchronous sequence circuit, all the flip-flops are operated by the common clock signal. So all the flip-flops, their output will change at the same time. Okay, yes or no? This I told you. In the synchronous sequential circuit, all the flip-flops are operated by the common clock, same clock signal. So all the flip-flops outputs will change at the same time. Okay. So now let's solve this question by this method number 2. I can say to solve this question, the method number 2. Very simple. What is given to you? The initial state, that is Q2, Q1, Q0, 0, 0, 0. You can see this is Q2, this is Q1, this is Q0. You can see this is Q0, Q1. So you can see, and Q2, Q1, Q0, that is 0, 0, 0. That is given to you. Okay. Now you can see this common clock is input to all these flip-flops. So this is a synchronous circuit basically. All the flip-flops are operated by the common clock signal. Now you tell me, what will be the next state? Notice all these flip-flop, these are positive edge triggered. Okay, all these flip-flop, they are positive edge triggered. So basically the initial state is given to you. It simply means that somewhere, at some point of time, somewhere, this Q2, Q1, Q0, this is 0, 0, 0. Okay, now you know that all these flip-flop, these are positive edge triggered. So at the positive edge of the clock, at the rising edge of the clock, they will respond to the inputs. Okay, these flip-flop, they will respond to the inputs at the rising edge of the clock. So this next state we need to find, means after the next rising edge, after the next positive edge, what this Q2, Q1, Q0 will become. This is what we need to find. This is called next state. Next state we need to find. Now you tell me. You can see this T is equal to 1. Okay. Remember one thing, that at this point, the flip-flops will not respond to the inputs. The flip-flops will not do anything, but these wires will do. Yes or no? You can notice this T equal to 1, this is ready. The flip-flops are not ready. The flip-flops will be active only at the positive edge of the clock. But you can see all the remaining things will be ready. So this T equal to 1 and this Q0 equal to 0, because this connection is there, this wire is there. So I can say this T is equal to 0. Yes or no? The flip-flop are not ready. They are not active at this point, but everything else will be active. Everything else will be ready, because wires, these wires, they don't depend on the clock. Yes or no? These wires, they don't depend on the clock. Only flip flop is operated by the clock. So you can see right now flip flops are inactive. At the rising edge, they will be active. They will respond to the inputs, but the wires, they are not depending on the clock. So you can see this Q1 is zero. So this T, this also will be zero. So okay, this is the current situation. Now you can see at this rising edge, what will happen? These flip flops, they will respond to the inputs. And remember, this is a synchronous circuit. So all the flip flops, they will respond to the inputs at the same time. Okay, so you can easily notice that at the same time, all these flip flop, they will respond to the input. So you can see this flip flop, because this is t equal to 1. So you can see, look at this flip flop here, t equal to 1. So the next state, that will toggle. Yes or no? The next state will toggle. You already know. Very simple. Okay, so what I'm saying, that this is the situation here. This is the situation here at this point. Okay, and now let me show you the situation. Let me show you the situation here at this point. Okay, so you can see that at this rising edge, what is going to happen? These T flip flop, they are synchronous. You can see they are operated by this common clock, so they will change the state at the same time. They will respond to the inputs at the same time. So you can see, look at this T flip flop, because T equal to 1, so the state will change. You already know the behavior of T flip flop, so you can see the state will change and it will become 1. Look at this T flip flop. Here T equal to 0. Notice T equal to 0. The input is 0. In the T flip flop, if T equal to 0, then the state will not change. So you can see this 0 will remain 0. The state will not change. And you can see for this T flip flop also, you can see this T equal to 0. So the state will not change, and you can see this 0 will remain 0. Okay, that's it. So you can see that here, what this Q2, Q1, Q0 will become, that will become 1, 0, 0. This will be your answer. I hope you understood. So this is the complete explanation of this question. Is it clear to everyone? Let me know. Very simple question. Remember, this is a synchronous sequential circuit. So all the T flip flop, they will respond to the inputs at the same time. All the T flip flops, they will change their state. They will change their output at the same time. Okay. So you keep everything ready, and when this rising edge will come, then at the rising edge, the flip flops, they will respond to the inputs. That's it. Simple. I hope it is clear. Let's solve this question. Analyze the given synchronous sequence circuit. Find the next state if the initial state is Q2, Q1, Q0 equal to 1, 0, 1. So let's solve it. You can see the initial state is given to you. So let me write it here. The initial state Q2, Q1, Q0, that is 1, 0, 1. And of course, what this means? This simply means that Q2 is MSB and Q0 is LSB. Okay, this is what you have. So here you can notice this is Q2. Okay, so let me basically write that. Okay, this is Q2, this is Q1, this is Q0. Let me write it, this T0, this T1, this T2. Okay, and you can see Q2 is 1, Q2 is 1, Q2, Q1, Q0, that is 1, 0, 1. So you can see this is 0, this is 1. Okay, simple. This is the situation right now. Now let's write the flip flop input equations, because that is the step number 1. So you can see step 1, that is write the flip flop input equations. Flip flop input equations. So here you can notice this T0, that is fixed 1. T0 is equal to 1. What is T1? You can see T1 is Q0. T1 is Q0, you can see. And what is T2? T2 is Q1. Simple. Okay, so we have written the flip flop input equations. Now what is the step number 2? State table. Correct? So let's see the step 2. We will draw the state table. In the state table, I told you what you need to do. You need to draw present state. The present state is Q2, Q1, Q0. This is the present state. Present state followed by the flip flop inputs. The flip flop inputs, these are T2, T1, T0. Okay, and you can see the next state, q2 next, q1 next, and q0 next. This is the state table, simple. Okay, and here the input flip flop input equations that we have found. So let me write quickly that t0 is 1, and you can see t1 q0, t2 q1, t1 q0, t2 q1. Okay, this we have already found. Now let's see. So notice this is the present state, and these are the flip flop inputs, and you can see this is the next state. Simple. So here the initial state is given to you, that is 101. This is given to us. So tell me what will be the flip flop inputs. This is given to us present state 101. So what will be the flip flop inputs? You can see t0 is fixed 1, and t1 is q0. This t1, this is q0, so that is basically 1. And you can see t2, that is q1, so t2 is 0. Okay, simple. Now notice that this q2 next, who will determine q2 next? This q2 and t2, they will determine q2 next, correct? Because what is q2 next? In this diagram you can see this flip flop has output q2. So what will be the next q2? Means the q2 next, that will be decided by q2 and t2 only. For this flip flop, what will be the next state, what will be the next output, that will be decided by only t2 q2 only. So you can see that this q2, this t2, they will decide what will be q2 next. So tell me one thing, if t2 is 0 in the t flip flop, if the input is 0, then the next state, that will be same as the present state. So the next state q2 next, that will be same as q2. So here I will write 1. Simple, very easy. Now let's see what will be the q1 next. So q1 next will be decided by q1 and t1. q1 and t1, they will decide the q1 next. Okay, these two. So you can see t1 is 1 in the t flip flop. If the input is 1, then the next state, that will be complement of the present state. The present state, this q1 is 0, so the next state q1 plus q1 next, that will be complement, so it will be 1. Simple. Now you can see what will be this q0 next. This will be decided by q0 and t0. These two, these two will decide this q0 next. You can see here in the t flip flop, if the input t equal to 1, here t0 equal to 1, so the next state q0 next, this will be complement of the present state. Yes or no? This will be complement of present state. So this q0 next, this will be complement of q0. q0 is 1, so this q0 next will be 0. Okay, so that's it. So finally the answer is what? The next state is 110. So finally for this question the answer is 110. I hope it is clear. Okay, this is what the question was asking, what will be the next state, and that answer we have seen, that is 110. Simple, right? I hope you understood. Okay, now let's solve this question by method 2 also, just for understanding purpose. You know that in a synchronous sequence circuit, all the flip flops are operated by the common clock signal, and that is the reason all the flip flops, they will respond to the inputs at the same time, they will change their state at the same time. You can see in the synchronous sequence circuit, all the flip flops will change their output at the same time, because all the flip flops are operated by the common clock signal. Okay, so let's see it here. You can see that this is q2, because okay, q2, so let me write it q2 q1, this is q0, let me call it t0 t1 t2, and q2 q1 q0, that is 101. This is 1, this is 0, this is 1. This is given to you. Now the situation basically is like this. You have this clock. At some point of time, okay, this is the rising edge, because remember all the t flip flop, all the flip flops, they are positive edge triggered, correct? So here you can see at some point of time, this q2 q1 q0, this is given to you 101. Okay, and remember the flip flops are inactive at this point, because flip flops will respond to the inputs at the rising edge, because all the flip flops are positive edge triggered. So you can see the wires, they don't depend on the clock. So here you can see that this T0 will be 1. So keep everything ready. This T0 is 1. And you can see this T1. This T1 is equal to 1 because this wire does not depend on the clock. Okay, so this 1 will be here. This T2 will be equal to 0. Okay, so everything is ready right now. At this moment, everything is ready. So you can see this is the situation at, at this point of time. Okay, at this point of time, this is the situation. Now let's see what will be the situation after the rising clock age. Okay, means here what is the situation we need to find. You can see q2, q1, q0, 101, this situation. And after the rising age, what will be q2, q1, q0? This is what we need to find. Okay, so first, what was the previous situation? Let me just quickly write. You can see this is 1 and okay, right. So you can see. Okay. Now you can see basically this is the situation at this point. Now, after the rising age, at this rising age, what will happen? All the flip flops, they will respond to the inputs. And because this is a synchronous circuit, all the flip flops are operated by the same clock. So they will, all the flip flops, they will respond to the inputs at the same time. They will change the state at the same time. Correct? So you can see that, look at this flip flop. Here, this T input is 1. So what will be the next state? At this rising age, what will happen? This state will change because T equal to 1 in the T flip flop. If the input is 1, then at the rising age, the state will change. The state will toggle, I can say. So here you can see it will become 0. Look at this T flip flop. Here you can see this T1 is also 1. Okay, remember all these flip flops, they are responding to the input at the same time. They will give the output, they will change the output at the same time. Okay, so you can see this for this flip flop, T1 equal to 1. So definitely this state will also toggle, means the state will change. And what about this T flip flop? You can see this is T2 equal to 0. So the state will not change. This state will remain as it is. So you can see this Q2 is 1, Q1 is 1. Okay, and you can see this Q0, this is 0. So this is your answer. Means if this is your present state, then this will be the next state. After a rising age, it will happen. Okay. Simple. Means from this state, you will go to this state after one clock pulse, or I can say after one rising age. Very simple. I can also say after one clock pulse, because in one clock pulse, in one clock cycle, in one clock pulse, you have one rising age, one falling age, one low level, one high level, that we already know in the previous lectures we have seen. So I can say that if this is your current state, then after one clock pulse, or I can say after one clock cycle, or I can say after one rising age, this will be the next state. This is what the question is asking, that find the next state. If the initial state is 101, so the next state will be 110. Okay, very simple. So you can see we have solved this question by using two methods. Okay, using both the methods, we got the answer, that is 110. I hope it is clear. Let's solve this question. Analyze the given synchronous sequence circuit. Find out the state after 4 clock cycles. We need to find the state after 4 clock cycles. If the initial state is 0, 0, 0. Now this is an interesting question, so let's solve. Again, remember, this is basically synchronous sequence circuit. So you already know how to analyze the synchronous sequence circuit, right? What we will do? The step number 1, that is, you write the flip flop input equations, correct? So you can see, remember, this is a synchronous sequential circuit. You already know how to analyze it. What is the step number 1? Step number 1 is you write flip flop input equations. Okay, what are the flip flop inputs here? You can see this Q2 is MSB, this Q0 is LSB. Okay, this Q2, so let me just quickly write it: Q2, Q1, Q0, this T0, this T1, T2. Okay, now Here the flip-flop input equations, you can see that T0 is fixed, that is 1. T1, you can see T1 is same as Q0, T1 equal to Q0. And you can see T2, that is Q1. Okay, these are the input equations, flip-flop input equations. What is the step number 2? In the step number 2, we will draw the state table, correct? Step 2. Now we will draw the state table. State table means input followed by output. Okay, so very simple. Present state, that is also input, because remember the next state is the output. We need to find the next state, that is the output. That will depend on present state and flip-flop inputs, correct? So you can see that the present state, that is Q2, Q1, Q0, Q2, Q1, Q0, this is the present state. And you can see the flip-flop inputs T2, T1, T0. These are the flip-flop inputs. And the next state we need to find Q2 next, Q1 next, and Q0 next. This is what we need to find. Simple. Okay, what we have so far, let me quickly write. You already know that T0 is fixed 1, T1, you can see T0 is fixed 1, T1 is Q0, T2 Q1, T1 is Q0, and T2, that is Q1. This we have already found. Okay, now let's quickly see. The initial state is given to you, that is 0, 0, 0. This is given to you 0, 0, 0. Now notice this question is so easy. This is very easy to find. The flip-flop input equations very easy to find. This is given to you. Now notice the question will be so easy. You can see first this is given to you. Let's quickly find what will be T2, T1, T0. T0 is fixed, that is 1. T1 is Q0, T1, that is Q0, so that will be 0. T2 is Q1, T2, that is Q1, so you can see T2 will be 0. Now notice, now we need to find Q2 next, Q1 next, Q0 next. So tell me this Q0, this Q2 next, if I want to find, who will decide, who will determine Q2 next? Q2 and T2? Okay, yes or no? This Q2 next, this Q2 and T2, these two will determine the Q2 next. That you already know. Okay, so tell me, we have this Q2 means this present state, that is 0, and T2 is 0. So tell me, in the T state, in the T flip-flop, if T input is 0, then the next state, that will be same as the present state. Q2 next will be same as Q2. So I can say it will be 0. So easy, yes or no? Now let's see, what will the Q1 next? Who will determine this Q1 next? Q1 and T1? Yes or no? These two, Q1 and T1. These two will determine what will be Q1 next. Okay, so let's see. Notice this T1 is 0. In the T flip-flop, if T input is 0, then the next state will be same as the present state. So I can say that Q1 next, that will be same as Q1, so it will be 0. Next, what about this Q0 next? Who will determine Q0 and T0? You can see this T0 is 1. In the T flip-flop, if T input is 1, then the next state will be complement of the present state. So I can say this Q0 next, that will be 1. Okay, very simple. But remember, so far we have only done 1 clock cycle. The question is asking that what will be the state after 4 clock cycle? After 4 clock cycle, we need to find the state. But notice so far what we have found, that if this is your current state, this will be your next state. So 1 clock cycle we have found, means if this is your present state of the circuit, then after 1 clock cycle, this will be the next state. But we need to find after 4 clock cycles. Okay, so you can see now this will become our present state. Yes or no? Now we need to see from 001 where we will go. Please notice, from 000 we are going to 001. Then after the next clock cycle, after the next rising edge, what will happen? Means from 001 where we will go. This is what we need to find. Okay, so let's find. Now you can see this 001. This is our present state now. Simple. Now tell me what will be T2, T1, T0. T0 is fixed, that is 1. T0 is fixed. T1 is Q0. T1, that is Q0. So you can see this Q0 is 1, so T1 will be 1. T2 is Q1. This T2, this will be same as Q1, means it will be 0. Okay, now let's see. What will be Q2 next? That will be decided by T2 and Q2. You can see T2 is 0. So the next state will be same as the present state. So you can see I will write 0 here. What about this Q1 next? This will be decided by T1 and Q1. You can see T1 is 1. So the next state will be complement of the present state, means here I will write 1 because T1 is 1. So the next state Q1 next, that will be complement of Q1. Q1 is 0. So you can see complement of Q1, that means 1. Okay. Next you can see what will be Q0 next. That will be decided by T0 and Q0. T0 is 1. So the next state will be complement of the present state, means you can see it will be 0. So notice from this state 0, 0, 1, we will go to 0, 1, 0. Means after this state, after one clock cycle, we will go to 0, 1, 0. Now let's see from 0, 1, 0 where we will go. Okay, let me make the diagram here, basically state diagram for better understanding. The question has given us that the initial state Q2, Q1, Q0, that is 0, 0, 0. This question has already given to us. Okay, and we have found that if we are in this state, then the next state will be what? This we have found. The next state will be 0, 0, 1. You can see from 0, 0, 0, we will go to 0, 0, 1. Okay, so we will go to 0, 0, 1 after one clock cycle. After one clock cycle, or I can say basically after one rising edge, because all the flip flops they are positive edge triggered. So I can say after one rising edge, basically from this state we will go to this state after one rising edge. From 0, 0, 1, where are we going? Means after one rising edge. After one rising edge, we will go to which state? From 0, 0, 1, we are going to 0, 1, 0. Okay, we are going to 0, 1, 0. Simple. Now let's see from 0, 1, 0 where we will go. So this is 0, 1, 0. Now this is our present state now. Okay, so tell me what will be T2, T1, T0. T0 is fixed, that is 1. T1, that is Q0. T1 is Q0, so it will be basically 0. And T2, that is Q1, so it will be 1. Now let's find what will be Q2 next, Q1 next, and Q0 next. You can see what will be Q2 next. That will be decided by Q2 and T2. Okay, so you can see T2 is 1. In the T flip flop, if the input is 1, then the next state will be complement of the present state, means the next state will be 1. Simple. Now let's see what will be this Q1 next. This will be decided by Q1 and T1. You can see T1 is 0. In the T flip flop, if the input is 0, then the next state will be same as the present state, so I can say it will be 1. What will be Q2 next? That will be decided by T0. What will be Q0 next? Q0 next will be decided by T0 and Q0. So you can see T0 is 1. In the T flip flop, if the input is 1, then the next state will be complement of the present state, so I can say it will be 1. So you can notice that from 0, 1, 0, we are going to 1, 1, 1. From this state 0, 1, 0, after one clock cycle, we will go to 1, 1, 1. After one clock cycle, means after one rising edge, we will go to 1, 1, 1. Notice the question was asking that this is the initial state, then after 4 clock cycle, we will go to which state? So you can see from this state, after one clock cycle, we will go here. After 2 clock cycle, we will go here. After 3 clock cycle, we will go here. But the question is asking after 4 clock cycle, means one more time we need to do. Means from this state, after one rising edge, after one clock cycle, where we will go, this is what I need to find. Okay, so let's see. Now you can see that this 1, 1, 1. Now this will be our present state. Now we are in this state 1, 1, 1. So let's see what will be T2, T1, T0. T0 is fixed 1. T1, that is Q0. And T2, that is Q1. Okay, so 1, 1, 1. Now let's see. Notice one thing. What will be Q2 next, Q1 next, and Q0 next? All these T values, these are 1, 1, 1. In the T flip flop, if the input is 1, then the next state will be complement of the present state. Yes or no? The next state will be complement of the present state. Here you can see all the T flip flop have input 1, 1, 1. So basically the next state will be complement of the present state. So I can say that these next state, they will become complement of these present state. So we will go to 0, 0, 0. Means notice from this 1, 1, 1, after one clock cycle, where are we going? We are going to 0, 0, 0. we are going to 0 0 0. Okay, I hope it is clear. Simple, right? So what will be the final answer? You can see, if I start in this state, then after 4 clock cycle, where I will go? You can see, if I start in this state, then after 1 clock cycle, 2 clock cycle, after 3 clock cycle, and after 4 clock cycle, I will go to 0 0 0 only. Yes or no? Here I will go after 1 clock cycle, here I will go after 2 clock cycle, here I will go after 3 clock cycle, and here I will go after 4 clock cycle. So you can see that from 0 0 0, basically the idea is that from 0 0 0, after 4 clock cycle, after 4 clock cycles, or I can say after 4 rising edges, or I can say after 4 clock pulses, basically we will go to 0 0 0. This is the final answer. I hope you understood. Simple, right? Now remember, what is the benefit of this state diagram? If I ask you, after 5 clock cycle, where we will go, let me know. What will be the answer? So you can see, from this state, after 4 clock cycle, where I will go? After 4 cycles, where I will go? I will go to 0 0 0. Tell me, from here, after 9 cycles, where I will go? Tell me. You can see, because this is a loop here. So you can see, from here, if I start, after 4 clock cycle, I will go here. Then after 8 clock cycle, I am here. Then in the 9th cycle, after 9th cycle, I will go to 0 0 1. Do you agree with me? Yes or no? Because this is a cycle here. If I start from here, then you can see, after 1, after 2, after 3, after 4, after 5, after 6, after 7, after 8, after 9. So you can see, after 9, I will go to 0 0 1. Do you agree? And tell me, from here, if I ask you, let me know, after 51 cycles, where I will go? Tell me, after 51 cycles, just use the modular arithmetic. Basically, you find, if I divide by 4, then what will be the remainder? Because notice, if I start here, then after every 4 clock cycles, I will come back here. Yes or no? If I start here, then after 4 clock cycle, I will come back here. After 8 clock cycle, I will come back here. After 12 clock cycle, I will come back here. So you can see that after 48 clock cycle also, I will come back here. Then only 3 more cycles I need. Yes or no? 48. If I start from here, then after 48 clock cycle, I will be here. Then after 49, I will be here. After 50, I will be here. After 51, I will be here. Okay, so the answer will be 111. Okay, very easy. I hope it is clear. Correct? Okay, so all these points, I hope all of them are clear. So you can see, this is the state diagram. Okay, this is the state diagram, and this is the state diagram, and this is basically the extra information that I shared with you for this question. I hope it is clear. I hope you are feeling confident in the analysis of synchronous sequential circuit. Okay, simple. Let's solve this question now. Analyze the given synchronous sequential circuit. Find out, after 4 clock cycle, what will be the state? The question is asking, find out the state. Find out the state after 4 clock cycles, if initial state is Q2, Q1, Q0 equal to 101. So pause the video and try to solve this question. So let's solve this question now. You can see, this is a synchronous sequential circuit because all the flip-flops are operated by the common clock signal. And the initial state is given to you, that is Q2, Q1, Q0 equal to 101. So you can see this is Q2. You can see this is Q2, Q1, Q0. Let me call it T0. Let me call it T1. Let me call it T2. Okay. Now, what is the step number 1? In the analysis of synchronous sequential circuit, the step number 1, that is, you write the flip-flop input equations. Okay. You write the flip-flop input equations. So what are the flip-flop input equations? You can notice that T0 is fixed, that is 1. T1 is Q0. And you can see that this T2 is Q1. Okay. So this is the step number 1. What is the step number 2? You make the state table. So let's make the state table now. So state table we need to make. In the state table, basically the inputs followed by output. The output is next state, and the next state, that is a function of present state and flip-flop inputs. So you can see that in the state table, what I will do, I will write Q2, Q1, Q0. This is the present state. Okay, I will write the present state, and I will write the flip-flop inputs also, T2, T1, T0, and I will write the next state. We need to find the next state, Q1 next, Q2 next, and Q0 next. Okay, so very simple. I hope you understood. Now let's see here. Notice that this is the present state. This is present state. These are flip-flop inputs, and you can see this is the next state. And you already know that the next state, the Q next, that is a function of what? That is a function of inputs and Q. That is the same thing we are doing here. This is the Q, means this is the present state, and these are the inputs. So you can see that this is the output, and this is a typical truth table. Yes or no? Do you agree? This is a typical truth table. These are the outputs, these are the inputs. So remember, this is a typical truth table here. Outputs, and these are the inputs. Okay. Now what we have so far, what we have found, the flip-flop input equations, we have found that T0 is 1, T1 is Q0, T2 is Q1. Okay, this we have already found. Okay, simple. So now let's see. The question is saying that the initial state is 101. After 4 clock cycle, we will go to which state? So the initial state is given to you, that is 101. 101, this is given to you. This is the present state. Now let's find what will be the next state after 1 clock cycle. So you can see Q2, Q1, Q0 we have. Let's find the T2, T1, T0. You can see T0 is fixed, that is 1. What is T1? This is Q0. What is T2? This is Q1. Okay, very simple. Now let's find what will be next state. So you can see Q2 next. This will depend on Q2, T2. Yes or no? Because this Q2, this is the output of this T2 flip-flop. This Q2, this is the output of T2 flip-flop. So the next state of this T2 flip-flop, that will depend on T2, Q2. Correct? So you can see this Q2 next. This will be determined by T2, Q2. Here you can see T2 is 0. So in the T flip-flop, if the input is 0, then the next state will be complement of the, will be same as present state. Yes or no? In the T flip-flop, we already know that if T input is 0, then the next state, that is same as the present state. So I can say I will write 1 here. Okay, now let's see here. T1, T0, they are 1, 1. In the T flip-flop, if the input T is equal to 1, then the next state, that will be complement of the present state. Yes or no? So you can see this Q1 next, Q0 next, they will be complement of Q1, Q0. So Q1 next will be complement of Q1, and this Q0 next, this will be complement of Q0. Okay, so very simple. I hope you understood. So I can say that from 101, we will go to 110. Okay, let me draw the state diagram here. You can see initially we are in this state, Q2, Q1, Q0 equal to 101. We are initially in this state. After 1 clock cycle, we will go to 110 state. We will go to 110 state after 1 clock cycle, or I can say after 1 rising edge, because remember the flip-flops are positive edge triggered here. In this question, the flip-flops are positive edge triggered. So I can say that if you are in this state 101, then after 1 clock pulse, after 1 rising edge, we will go to 110. Okay, now from this 110, where we will go, what will be the next state? So you can see, you assume that 110 is your present state. This 110, let's assume that this is your present state. So take it as a present state. Now let's find what is T2, T1, T0. You can see T0 is fixed 1. T0 is fixed. T1 is Q0. T2 is Q1. Okay, now let's see what will be the next state. Notice This T2 and this T0, they are 1 1. T2 and T0, they are 1 1. In the T flip flop, if the input is 1, then the next state will be complement of the present state. Yes or no? So you can see these next state, these two next state, they will be complement of these states. Correct? So I can say that Q2 next, that will be complement of Q2, and Q0 next will be complement of Q0. Simple. And you can see here T1 is 0. In the T flip flop, if the input is 0, then the next state will be same as the present state. So you can see that this Q1 next will be same as Q1. So remember, from 110 state, after one clock pulse, we will go to 011. We will go to 011. Okay, now let's see. Assume that 011, this is your present state. Then after one clock pulse, where we will go? So you can see 011. Let's find T2, T1, T0. T0 is fixed 1. T1 is Q0. T1 is Q0. That is 1. T2 is Q1. T2 is Q1. Okay, so now we have 111. Now notice in the T flip flop, if the input is 1, then the next state will be complement of the present state. So you can see these next state, they will be complement of these present states. Yes or no? So basically we will get 100. So remember, then from 011, the next state after one clock pulse, that will be 100. So here, from here we will go to 100. Now let's see, from 100 where we will go. From 100, where are we going? Because notice what the question was asking. The question was asking after 4 clock cycle, we will go to which state? We are in this state. After 1 clock cycle, we will go here. After 2 clock cycle, we will go here. After 3 clock cycle, we will go here. Now the question is asking after 4 clock cycle. So we need to find that from 100 state, what will be the next state after 1 clock cycle or after 1 rising edge. Okay, because all the flip flops are positive edge triggered. So I can say, when I say after 1 clock cycle, it simply means after 1 rising edge. Now let's see. So from 100, we will go to which next state? Notice, let's find T2, T1, T0. T0 is fixed, that is 1. T1 is Q0. T2 is Q1. Okay, now let's see. Here you can see this T2, T1, they are 0 in the T flip flop. If the input is 0, then the next state will be same as the present state. So you can see that these next state, they will be same as the present state. So I can say it will be 10. And you can see T0 is 1 in the T flip flop. If the input is 1, then the next state will be complement of the present state. So you can see that this Q0 next will be complement of Q0. Okay, so we are going to 101 state. Okay, we are going to 101. Notice from here, the next state is 101. After 1 clock cycle, we are going to 101 state. Okay, so very simple, that after 4 clock cycle, basically you are going to 101 state. Okay, the answer is like this, that from this state, Q2, Q1, Q0, 101, if you are in this state, then remember after 4 clock cycles or clock pulse, or after 4 rising edges, after 4 clock cycles, where you will go? You will go to 101 only. Okay, yes or no? Now many questions you can answer here. Tell me, if I start in this state, then tell me after, let me know that after 20 cycles, where I will go. After 20 cycles, in which state I will go? Let me know. You can see from this state, after 4 cycles, I will come back here. After every 4 cycles, I will come back here. So you can see this 20 is multiple of 4. So you can see after 20 cycles also, I will come back here, means 101. Okay. Now let me ask, after 101 cycles, where you will go? After 101 cycles. So you can see after 100 cycles, I will come back here. Then after 101 cycles, I will go to 110 state. Okay, so like this. I hope you are getting the point. So very simple. We have done the analysis of this synchronous sequential circuit also. So I hope you understood. And I hope you are finding some confidence in this topic. Now we are going to solve gate PYQs based on synchronous sequence circuit. 100 plus gate PYQs we are going to solve from all the gate branches: gate CS, EC, electrical, instrumentation, biomedical. Basically, from all the gate branches, the gate PYQs on synchronous sequence circuits we are going to solve. Okay, after solving 100 plus gate PYQs, you will feel a lot of confidence, and I am very sure that this sequence circuits, this topic will become your favorite topic in the digital logic. Okay, and this is the target. I want to make sure that sequence circuit should become your favorite topic in the entire digital logic. Okay, so let's start. Let's solve gate 2011 question, gate CS 2011 question. Consider the following circuit involving three D type flip flops used in a certain type of counter configuration. You don't have to worry about what is counter configuration, what is counter. You don't have to worry. You can see some circuit is given to you, it contains flip flops, and you can solve it. You have the knowledge of flip flop, you know all about flip flops, and this is a synchronous sequence circuit, so you can solve this question. You don't have to worry about these fancy words about what is counter. You don't have to worry about this word. Okay, so basically you have a circuit made of flip flops, containing flip flops, and this is a synchronous circuit, so we can analyze it and we can solve this question. So you can see we have three D type flip flops are there. If at some point, if at some instance prior to the occurrence of clock age PQR, they are having the value 010, then what will be the value of PQR after the clock age? Notice here all these D flip flop, they are positive age triggered. You can see all these are positive age triggered D flip flop, and you can see that this is a synchronous sequence circuit because all the D flip flop, they are operated by the common clock. The same clock signal is the input to all the D flip flop. So first of all, you can notice this is a synchronous. This is a synchronous sequential circuit. This is the first point to notice. Okay. The second point is that all these D flip flop, these are positive edge triggered D flip flop. And what this question is saying, read this. The question is saying that at some point before the occurrence of clock age, means this is the clock, all the D flip flop here, they are operated by the same clock signal. So you can see this is the clock, and you can see before this positive age, just before this positive age here, you can see PQR. What is P, what is Q, what is R? These are basically output of the flip flop. So means I told you that flip flop output combination, that is called state. So you can see what the present state of the circuit here, what the present state of this circuit. So tell me what is the present state here. Here PQR, that is 010. So this is the present state of the circuit. Very simple. So you can see that the question is saying that at some instance prior to the occurrence of the clock age, this is the clock age, before this PQR, this is 010, and the question is asking that what will be the value of PQR after the clock age, means at this rising age this flip flop will respond to the inputs. So you can see at this rising age the state will change, yes or no. So basically the question is saying that after this clock age here, what will be PQR? I hope you understood. So in simple words, the question is asking that this is the state PQR equal to 010, and after one clock cycle, after one clock age, after one rising age, after one clock pulse, what will be the next state? This is what the question is asking. This is in the simple words. Okay, I hope you understood. So far, remember, we have just understood what this question is saying. Everything in this question we have understood. Okay, now let's solve this question. This is a synchronous sequential circuit, and we already know how to analyze synchronous circuits. What are the steps? The step number one, that is you write the flip flop input equations. For each flip flop, you write their input equation. Then you draw the state table. How to draw the state table? Very simple. State table means present state plus flip flop inputs followed by next state. Okay, this will be your state table, means input followed by output. Next state we need to find, so that is the output. And to find the next state, that will depend on present state and flip flop inputs, so that will be your input followed by output. Okay, and if there is any need, then draw the state diagram. Actually, in this question, we don't need to draw the state diagram because only after one clock pulse, what will be the state? This is what the question is asking. The question is not asking like after three or after four or after five clock pulse, what will be the state? Okay, here only after one clock pulse, after one rising edge, what will be the state? This is what the question is asking. So let's solve this question now. What is the step number one? Step number one is you write flip flop input equation. Flip flip flop input equations. Because this is a synchronous sequential circuit. In the analysis of synchronous circuits, this is the step number one. You write the flip flop input equations. Here you can notice we have three D flip flop. Okay, for a moment, here you have D, D, D. So let me call it DP. Let me call it DQ. Let me call it DR because these are D, D, D. Okay, so let me distinguish them. DP, DQ, DR, because you can see this is the output P, this is the output Q, this is the output R. Okay, so that is the reason. Now tell me what is DP here. Let's write the equation for DP. So notice this DP, this is the wire. Okay, so from where this wire is coming, you can see this wire is basically coming from this R. So did you notice that DP is equal to R? Notice this R means the output of this D flip flop, that is R. This R is going like this, and this is a DP. So DP is equal to R. Simple. What is DQ? This is DQ. Okay, let's see. This is, you can see here we have NOR gate. Correct. What are the inputs for this NOR gate? You can see one of the input is P. So one of the input is P. Another input is R. So you can see for this NOR gate, one of the input is P. Another input is R. So NOR. P or R whole bar. Okay. Or I can say P bar, R bar. Now let's see what is DR. Let's see DR. Remember, this is the step number one. We are writing the flip flop input equations. For this flip flop, the input is DR. Okay, so you can see for this DR, this is the wire. You can see, let's write the equation for DR. There is an AND gate here. In this AND gate, one input is Q, and another input is R bar. Notice for this D flip flop, the output is R. So this Q bar will be R complement. Yes or no? So it's QR complement. Okay, is this clear? Very simple. So here you can see that this will be basically R bar. Okay, if this is R, then of course this will be R bar. So let me write here like this. Simple. Okay, so we have found the flip flop input equations. Now let's see what is the next step. The next step is you make the state table. Okay, so let's make the state table. In the state table, what we need to do? We need to write present state, flip flop inputs, next state. Very simple. Okay, so let's see what is the present state. PQR. This is the present state. Okay, and what are the flip flop input equations? These are DP, DQ, DR. These are the flip flop inputs. Okay, followed by next state. You can see P plus means next state, Q plus means next state, R plus means next state. Okay, simple, very easy. Here you can see, let me quickly write that in this, you can see that this is basically your present state. Okay, PQR, this is the present state, because here you can see in this diagram, the output of flip flops, these are PQR. Okay, correct. So here you can see the question is saying that present state is state of a circuit, state of a sequential circuit, that is the flip flop output combination. So here you have flip flop outputs, these are PQR, and initially they are 0 1 0. This is the present state of the flip flop, present state of the circuit basically. Okay, present state of the circuit, that is 0 1 0. So you can see that this PQR, this is the present state, these are flip flop inputs, and these are the next state. Okay, and just notice one thing in this table, what we need to do, already what is given to you, that PQR, that is 0 1 0, this is given to you. Okay, PQR, that is 0 1 0, this is given to you. Now what we need to do, first from here we will find this. Okay, then what we will do, then from these two we are going to find this. Correct, this is what we are going to do. And remember, this state table is simply your typical truth table, because you already know that the next state, that is always a function of flip flop inputs and present state. Yes or no? So that is the reason you can see this is the present state, these are the flip flop inputs. So you can see that next state, this is the next state that we need to find. This depends on these inputs. So remember, these are the inputs, this is the output. So remember, this state table, this is just a typical truth table, nothing else. Here you can see what is this q, this is the present state, and what is this I, this is the flip flop input combination, or I can say flip flop inputs. Simple. I hope you understood. Now let's solve it. So you can see what we have so far, what we have found so far. Let me quickly write. You can see dp is equal to r. This we have found. So let me quickly write here that dp will be same as r, dq will be same as p or r whole complement, and dr, you can see that will be qr bar. That will be qr bar. Okay, so you can see this actually we have already found. So I'm quickly writing here. Now what is given to you, that pqr, these are 0 1 0. PQR, you can see 0 1 0, that is given to you, 0 1 0 PQR. Okay, now let's see what will be the answer here. So notice what will be dp dq dr. First let's find that, what that will be. You can see dp is equal to r, so dp that is equal to r, so you can see dp will be 0. dq is equal to p or r whole complement. You can see dq, this will be p or r whole complement. So you can see 0 or 0, that is 0, whole complement, that will be 1. What is dr? That is qr bar. Qr bar. So that will be also 1. Okay, simple. Okay, notice here what is dr. Dr is AND of two signals. One signal is q, another signal is r bar. Correct. Okay, so you can see that from here we have found this. Okay, you can see that this was already given to us, and now we have found this. Very easy. I hope you understood. Now let's see what will be next state. So what will be p plus? Who will determine p plus? P and dp, they will determine p plus. Correct, because remember what is p. P is the output of this flip flop. Okay, for this flip flop the output is p. So what will be p next? Who will determine? This dp and this p. Okay, the present state and the input of this flip flop, they will determine what will be the next output or next state of this, of this flip flop. Yes or no? So notice that who will determine this p plus? This p and dp, they will determine the p plus. Now in the d flip flop we already know that whatever is your d input, that will become your next state. Do you agree with me? In the d flip flop we already know the behavior of the d flip flop, that in the d flip flop whatever is your d input, that will become your next state. Yes or no? So remember, this will become your next state, that will be 0. Now let's see what will be q next. Who will determine q next? Q and dq, they will determine q next. Okay, so you can see that dq equal to 1. In the d flip flop whatever is the d input, that will become your next state. So you can see whatever is the d input, that will become your next output. So you can say I can write it 1 here. Similarly this dr is 1, so this will become the next state or next output, that will be 1. Okay, very simple, right? You can see this r plus, who will determine r plus? R and dr, they will determine r plus. Okay, but you can see because it is a d flip flop, in a d flip flop whatever is the d input, that will be your next output or next state. So you can see that basically because it is a d flip flop, so this 0 1 1, this as it is I can write as the next state. Okay, do you agree? So now I can say the answer is 0 1 1, means if you are in this state 0 1 0, if you are in this state pqr equal to 0 1 0, then remember after one clock cycle, after one rising age, we will go to 0 1 1, we will go to this state. Very simple. Okay, so this is your answer. Very easy. Do you agree? So for this question, the answer will be 011. Answer will be option D. You can see. Okay, means if you are in this state 010, then after one clock pulse, or I can say after one clock cycle, or I can say after one rising edge, because all these flip flop are positive edge triggered. So I can say after one rising edge, we will go to this state 011. So for this question, answer will be option D. Very simple. Now, this question we can solve using another method. So let's see that. This is the question. Now, do you remember that I told you synchronous sequence circuit? In the synchronous sequence circuit, all the flip flops are operated by the common clock signal. Okay, so that is the reason all the flip flops they will change their state at the same time. All the flip flops they will respond to the inputs at the same time. Okay, yes or no? This we have already seen. The synchronous sequence circuit means all flip flops are operated by the common or same clock signal. So I can say in the synchronous circuit, all the flip flops will respond to the inputs at the same time. They will change the state at the same time. Okay, so here in this question, you can notice what is given to us, that initially PQR is equal to 010, that is given to us. So remember, P, that is 0, Q, that is 0, PQR is 010, means Q is 1 and R is 0. Okay, because you can see initially this is given to you that initially PQR, that is 010. Now notice the question was saying that the question was basically saying that before the clock age, before the clock age, this PQR, this was 010. Okay, and the question is asking that after this clock age, after one rising age, what will be PQR? This is what the question is asking. So right now we are here. Right now we are standing here. Okay. Simple point that right now we are standing here. So if you are standing here, then you can see P0, Q1, R0. Notice these flip flops, they are inactive, means they will not respond to the inputs. They are inactive. But the wires and these logic gates, they don't depend on the clock. Do you agree with me? Please understand that flip flops they depend on the clock. They are operated by the common clock. So they are inactive right now. At this point, they are inactive because these flip flops will respond to the inputs at the rising edge only. So you can see at this point, the flip flops are inactive, but the wires, all these wires and all these logic gates, they don't depend on the clock. They will do their work. Okay, yes or no? So very simple point that note, the wires, the logic gates don't wait for clock. Yes or no? They don't wait for clock. They don't depend on clock. They don't wait for the rising edge. Okay, so very simple. They don't wait for rising edge, for the rising edge. Okay, so simple. All these points, I hope it is clear. So let's see. Let's make this circuit ready. Okay, then basically when the rising edge will come, then these flip flop they will respond to the inputs. So you can see that P0, Q1, R0 here. What will be this D input? Means you can notice that this R, look at this, R is already equal to 0, and this wire does not depend on the clock. Okay, so this R equal to 0, this signal is going, and like this. So this 0 is already available here. Very simple. Now let's see. What about this here? Notice this NOR gate, this logic gate, this does not depend on the clock. So for this NOR gate, you can notice that this P equal to 0. It's like that. This P equal to 0, and this signal is going here. So here this P equal to 0. Okay, and you can see the another signal is R equal to 0. So this R equal to 0, this signal is going and it is here 0. So you can see that this 0, 0, and this is NOR. So first you will do OR, then you will do complement. So basically this is 1. Simple, right? Now, what about this here? You can see this is the AND gate. This does not depend on the clock. Okay, so if this is R equal to 0, then here I can say it is 1. Correct? Because this is R equal to 0, so this is just complement, so it will be 1. So you can see that it is 1. and the another signal that is basically q equal to 1. So this is 1. So this is 1. Okay. What I'm saying that you just make this circuit ready. Means right now whatever I have shown you, this whole thing is basically at this point of time. Okay. Now the circuit is ready. Now the circuit is just waiting for the rising edge, because these flip flop they are inactive. They will respond to the inputs at the rising edge. Now let's see what will happen at the rising edge. Clear? Okay, so you can see I have shown you the situation. This entire situation I have shown you at this point. Now let's see the situation at the rising edge and after the rising edge. Okay, so what matters to us, let me write. You can see these d inputs, these are 0 1 1. Okay, these d inputs, these are 0 1 1. These are the d inputs. Okay, this is what matter to us. So that's it. So here you can see that at this rising edge what will happen, because these are d flip flop. In the d flip flop you already know that at the rising edge the next output, the next state, that will be same as the d input. Yes or no? So you can see that this d input, this will become the next state. The next state will become 0. This d input will become the next state, so this will become 1. This d input, this will become the next state, so it will be 1. Very simple, right? Yes or no? In the d flip flop we already know that in the d flip flop at the rising edge, at the active clock edge, whatever is the d input, that will become your next output or next state of the flip flop. So you can see that this d equal to 0, this will become the next state. D equal to 1, this will become the next state. And this d equal to 1, this will become the next state. So that's it. So you can see after this rising edge, this PQR, this will be 0 1 1. Okay, this is the answer. I hope it is clear. Simple. Okay, and remember, because this entire circuit, this is synchronous sequence circuit, all the d flip flop they are operated by the common clock signal. So they will, all these three flip flop, they will respond to the inputs at the same time. Yes or no? Because all these d flip flop they are operated by the common clock signal. So at this rising edge, all these three d flip flop they will respond to the inputs, they will change their output, they will change their state at the same time. Okay, so overall you can see that from 0 1 0, after one active clock edge, after one positive edge, we will go to 0 1 1 state. So this is the answer. So this is method. Which method did you like more? To be honest, the first method, that is better. Okay, if the question asks you like after 2 clock cycle, after 4 clock cycle, after 5 clock cycle, if this type of question is there, then method number 1 will be the best. This method, this is just for understanding purpose, nothing else. If the question asks you like after 1 clock cycle what will be the state, like in this question it is asking after 1 clock cycle what will be the state, so this method you can apply. This method will give you more intuition. But the first method that we have seen, making the state table, writing the flip flop input equations, that method is overall the best method. Okay, I hope you understood both the methods. Let's solve gate CS 2021 question. Consider a 3-bit counter. Don't worry about what is a counter, because remember this circuit that is given to you, this contains flip flop. You know all about flip flop. You know all about T flip flop. And this is a synchronous sequence circuit, because all the T flip flop they are operated by the common clock signal. This common clock signal, this is the input to all the flip flops. So basically, look at this circuit. Don't worry about this fancy name counter. After solving 100 plus gate PYQs, I will tell you what is counter, what is register. Everything I will tell you. Don't worry. But right now, our target is to solve 100 plus gate PYQs based on the knowledge of flip flops, based on the knowledge of synchronous sequence circuits. Basically, with the minimum amount of knowledge, with the minimum amount of concepts that we have studied so far, we can solve 100 plus gate PYQs. Okay, after solving 100 plus gate PYQs, then we are going to study what is counter, what is register. But one thing you will notice, that most of the counter questions, most of the register questions you can solve without knowing what is a counter, what is a register. That is the beauty, because ultimately what is a counter? This is just a combination of flip flop, and you know all about flip flop, you know all about sequencer, you know all about synchronous sequential circuit. Okay, so you can solve this question very easily. So let's solve it. Consider a 3-bit counter. Why 3-bit? Because we have 3 flip flops. So to represent the state of this circuit, we need 3 bits. Yes or no? the state of this circuit, this will be a combination of 3 bits. So you can see this is a 3-bit circuit, I can say, designed using T flip flop. We have 3 T flip flops are there. Assuming the initial state of the counter, means the initial state of this circuit, that is PQR equal to 0 0 0, what will be the next 3 states? The question is asking next 3 states. Here you notice one thing, that PQR, this is the state is represented as PQR. So tell me, PQR, which of them is MSB, which of them is LSB? Very simple, that this P will be MSB and this R will be LSB. Okay, so this is given to you. The state is represented as PQR, means P is the MSB and this R is the LSB. Simple. This is the one thing that you can notice. Okay. And the second thing you can notice is this is synchronous sequential circuit. This is the second thing you can notice. Okay, because the same clock pulse is the input to all the 3 flip flops. All these flip flop are operated by the common clock signal. Simple. Okay. Next, you can notice the question is saying that PQR equal to 0 0 0, means this PQR. This is your present state. Remember, for a circuit, this is a circuit containing flip flop. For a circuit, what is the state? State means flip flop output combination. So basically, you can see this PQR, these are the flip flop output combination. This is given to you, that is 0 0 0. Now the question is asking that what will be the next 3 states? So let's find. Because this is a synchronous sequential circuit, we already know how to analyze synchronous circuits. You can see these are the steps for analysis of synchronous sequential circuit. The steps are, first we will write flip flop input equations. This is the step number 1. For each flip flop you write the flip flop input equations. Then the step number 2, that is you draw the state table. And the step number 3, that is state diagram. We have already understood these steps. Now let's solve this question. So the step number 1, that is you write the flip flop input equations. Okay, so let me write step number 1. Write flip flop input equations. Okay, so here you can see the 3 flip flop that we have, their inputs. These are TP, TQ, TR. Okay, so what is TP here? Let me write TP. Notice this TP with signal is coming to TP, that is R. So remember, TP is same as R. You can see this R, this is TP. Okay, what is TQ? Let's see. TQ, that is same as P dash. Correct? Simple. Next, what is TR? TR, this is same as Q dash. Okay, very simple. So this is the step number 1. What is the step number 2? In the step number 2, we will make the state table. Okay, state table. In the state table, I told you what we will do. We will write the present state, that is PQR. Okay, PQR, this is the present state, and the question is saying that P is the MSB. Yes or no? So you can see we are drawing the state table. In the state table, present state followed by flip flop inputs. So these are TP, TQ, TR, and the next state. This is what we need to find. P plus, Q plus, R plus. These are the next state. Simple. Okay. Here, notice that this is given to you, that PQR, these are 0 0 0. Okay, the present state is given to you. Okay, this is given, that PQR equal to 0 0 0. Now what we need to do, notice in this state table, this is the present state and this is the flip flop inputs and this is the next state. So now notice what we will do. This is given to us. So first we will find from this given, first we will find this TPTQTR. Okay, and then from these two, from this and from this, from these two, we will find this. Okay, so I hope you understood. These are the steps. Now let's see. First, let's find this TP, TQ, TR. Okay, so you can see this is given to you, that initially PQR equal to 0 0. And what we have found, let's write. We have already found that TP equal to TPR. TP equal to R. What is TQ? TQ is equal to P bar. TQ is equal to P bar. And what is TR? TR is Q bar. Okay, simple. Now let's see quickly. From this 0, 0, 0, from this PQR, let's find TP, TQ, TR. So you can see TP is equal to R. TP, this is equal to R. So I will write 0 here. TQ is P bar. So that will be 1. TR, this is Q bar. So that will be 1. Now, what is the next step? You can see, let's find the P next, P plus. Who will determine P plus? Let's see. You can see that this P and TP, they will determine P plus. Okay, because notice what is a P? This P, this is basically output of this TP flip flop. Okay, so remember what will be P next? That will be determined by TP and what is the present value of P? Yes or no? What will be the next state of this TP flip flop? That will be decided by present state of this TP flip flop and what is the TP? Okay, yes or no? So that is the point here. I can say that this P and TP, they will determine what will be P next. So you can see in the T flip flop, if T input is 0, then the next state that will be same as the present state. So you can see next state will be same as the present state. Now notice this TQ equal to 1 and this Q next, we need to find who will determine Q next. Q and TQ. Q and TQ, they will determine what is Q next. Correct? So you can see here TQ equal to 1. In the T flip flop, if the input T is equal to 1, then the next state will be complement of the present state. So Q next will be complement of Q. So that will be 1. What about R? R plus means the next state here. So that will be determined by R and TR. R and TR, they will determine what is R plus. So here you can see TR is equal to 1. In the T flip flop, if the input is 1, then the next state will be complement of the present state. So I can say here it will be 1. So simple. Yes or no? So finally, I can say that, remember, okay, I can say that from this state, we are basically going to this state 0, 1, 1. 0, 1, 1. Okay, I hope you understood. Now notice, let me make the state diagram here. You can see the question is saying that initially we are in this state. Our circuit that is initially in the state 0, 0, 0. Now, from this state, after one clock cycle, we will go to this state 0, 1, 1. Okay. But remember, the question is asking that this is the initial state. What will be the next 3 states? Means if this is the initial state, then the next state will be 0, 1, 1. The question is asking what are the next 3 states. Means now we will assume that this is the present state. Then what will be the next state? Okay, then we will assume this is the present state. Then what will be the next state? So this is what the question is asking. Question is asking that if this is the initial state, then what are the next 3 states? This is what the question is asking. I hope you understood. Okay, so let's see. Now you can see this 0, 1, 1. This will, I will assume that this 0, 1, 1. Now this is the present state. Okay. Notice one more thing, that in this circuit, you can see all the T flip flop, they are positive edge triggered. Correct? So when I say after the next clock pulse, after the next clock cycle, it simply means that after the next rising edge. Okay, so here remember, initially we are in this state, and when I say after one clock pulse, after one clock cycle, or I can say the next state is this, what it means? It means that from this state, after one rising edge, we will go to this state. The same thing I can say that from this state, after one clock cycle, I will go to this state. Or I can say from this state, the next state is 0, 1, 1. Like that. Okay, very simple. Now let's see from 0, 1, 1 where I will go. So now this is the present state 0, 1, 1. Let's find TP, TQ, TR. TP is R. This TP. This is same as R. TQ is P bar. TQ, that is P bar. So that will be 1. TR is Q bar. TR is Q bar. So that will be 0. Okay, now let's see what will be P next, Q next, and R next. Now notice here TP, TQ, these are 1, 1. In the T flip flop, if the input is 1, then the next state that will be complement of the present state. Yes or no? So you can see that TP, TQ, these are 1, 1. So for these two flip flop, the next state will be complement of the present state. So I can say that this P next, Q next, this will be complement of these. So it will be 1 0. And you can see this TR, this is 0. In the T flip flop, if the input is 0, then the next state that will be same as the present state. So here I will write 1. Okay, simple. So you can notice that from this 0 1 1, from this state, the next state is 1 0 1. Or I can say from this state 0 1 1, after one clock cycle, after one clock pulse, after one rising age, we will go to this state 1 0 1. Okay, so you can see 1 0 1. Now let's see. The question was asking that if this is the initial state, then what will be the next three states? So next two states we have found. Now let's see what will be the third state. So now assume that this 1 0 1, this is the present state. This 1 0 1, you assume now this is the present state. So let's find TP, TQ, TR. TP is R. So, and this TQ, this is P bar. And this TR, this is Q bar. Okay, so here you can see simple. Now let's see. Notice this TP, TR, they are 1 1. In the T flip flop, if the input is 1, then the next state that will be complement of the present state. So you can see that P plus R plus, they will be 0 0. Simple. And let's see this TQ, this is 0. In the T flip flop, if the input is 0, then the next state that will be same as the present state. So you can see that will be 0. So you can see that we are going to 0 0 0. From this 1 0 1, we are going to 0 0 0. So from this 1 0 1, after one clock cycle, we are going to 0 0 0. We are going to 0 0 0. After one clock cycle, or I can say after one rising age, because all the flip flops, all the T flip flop, these are positive edge triggered. So I can say that from this 1 0 1 state, after one clock pulse, after one rising age, we will go to 0 0 0 state. Okay, and what the question was asking that this is the initial state. So what are the next three states? The next three states are 0 1 1, 1 0 1, and 0 0 0. Okay, this is the answer. So answer will be what? You can see answer is 0 1 1, 1 0 1, 0 0 0. Okay, so you can say 0 1 1, 1 0 1, 0 0 0. So answer will be option A. Very simple. I hope you understood. Okay, so this is how you can solve these questions. I hope you are feeling confident now. Okay, very simple, right? The synchronous sequential circuit questions, these are actually very simple. The step number 1, that is you write the flip flop input equations. Step number 2, you draw the state table. How to draw the state table? Very simple. In the state table, we will make column for present state, then flip flop inputs, then next state. Very simple. And then we will construct the state diagram. So these are the steps, simple steps, and very easily you can solve these questions. I hope you understood. Let's solve GATE CS 2005 question. Consider the following circuit. This sequential circuit is given to you, and this contains two D flip flops. And you can see this is synchronous sequential circuit because both the D flip flops, these are operated by the common clock signal. You can see the same clock signal. This is going as the input to both the flip flops. So you can see this is basically synchronous sequential circuit. This is synchronous sequential circuit. This is the first observation. Now you can see the flip flops are positive edge triggered. That is visible here. You can see this symbol basically means that the flip flops are positive edge triggered. So the flip flops are positive edge triggered D flip flop. Each state is designated as 2-bit string Q0 Q1. So tell me Q0 Q1, which of them is MSB, which of them is LSB? Q0 Q1. So it is clearly given that Q0 is the MSB. Okay, you can see Q0 is the MSB and Q1 is the LSB. So I can say that this flip flop, this is the MSB flip flop, I can say, and this is the LSB. Simple. Now, each state is designated as 2-bit string Q0 Q1. You already know that in any sequential circuit, what is the state of the circuit? That is flip flop output combination. Yes or no? So you can see flip flop output combination. That simply means Q0 Q1. This is the state of the circuit that we already know. And this is what is written here, that the state of this circuit, that is basically Q0 Q1, because this is the flip flop output combination. Let the initial state be 0 0. Okay, initially we are in the state 0 0. What is the state transition sequence? The question is basically asking the the state diagram. Basically state transition diagram we need to find. We need to start in this state 0 0, then we need to see what will be the next state, then we need to see what will be the next state, like that. Okay, so basically the state transition diagram or state diagram we need to find. Now let's solve this question. We have already seen that when you have synchronous sequence circuit, then how to do the analysis, what are the steps. The step number one, that is we will write flip flop input equation. For each flip flop we will write the input equation. Then the step number two, that is we will draw the state table. In the state table we will draw present state and flip flop inputs. Then we will draw next state. Then the third step, that is we will draw the state diagram. You can see in this gate 2005 question, it is basically asking the state diagram. So let's solve it. The step number one, that is write the flip flop input equations. Okay, so you can see what are the flip flop inputs here. You can see write flip flop input equations. So here you can see we have two flip flops, two D flip flop we have. Okay, let's for a moment let's call it D0 flip flop, let's call it D1 flip flop. So you can see that this D0, we need to write the flip flop input equation. So tell me what is D0 here. You can notice this D0, if you look at this D0 is same as Q0 bar. Okay, D0 is basically Q0 bar. And what is D1? Let's write the equation for D1. This D1. D1, you can see here we have XOR. Okay, and for this XOR gate, the inputs are Q0 and the another input is Q1 bar. So you can see that Q0 XOR Q1 bar. This is your D1. Is this clear? You can see Q1 bar and Q0. They are XOR. This is D1. So that's it. This is the step number one. Now let's see the step number two. That is we will draw the state table. Correct? Okay, so let's draw the state table. In the state table, I told you that we will write present state. Here you can see the present state is Q0, Q1. Okay, remember here the state is designated as Q0, Q1. What it simply means? It simply means that this Q0 is the MSB and this Q1 is the LSB. Okay, so you can see here I will write Q0, Q1. This is the present state. Q0, Q1. And this is the present state. Then flip flop inputs. The flip flop inputs, these are D0, D1. And what is the next state? We need to find the next state. Okay, so Q0 plus means this simply means next state. Okay, and this also means next state. Very simple. Now here you can notice in the state table, this is present state. Okay, this is a present state and these are flip flop inputs. And you can see this is the next state. Simple. Okay, and what is given to you in the question? It is given to you that initially we are in the state 0 0. This is given in the question, that you can see the initial state. You can see let the initial state be 0 0. So you can see this is given that initially we are in this state 0 0. Now this information is given. Now what we need to do? First, remember, from this given information, first we will find this D0, D1, and then from these two we will find this next state. Okay, so this is the sequence. I hope you understood. This is how we are going to solve it. Simple. Now let's solve it. You can see. So it is given that initially we have state 0 0, and let's write this what we have found. You can see we have found this D0, D1 equation. So let's write it here. What is D0? That is Q0 bar. And what is D1? D1 is Q0 XOR Q1 bar. Q0 XOR Q1 bar. If you remember one thing, this Q0 XOR Q1 bar, I can write it Q0 XNOR Q1. Okay, do you recall this property? Do you recall? We have this property, right? Note that if you have, P XOR Q bar, we can write it P XNOR Q also. Okay, so These are some properties, like some more properties. For example, p xor q whole complement, that is also p xor q. But if I do p complement xor q complement, that will be same as xor only. Okay, so all these properties actually we have already seen. You can just check the previous lectures, boolean algebra lectures. There we have already discussed all these properties. Okay, so anyway, now let's see here. So you can see this d1, this is q0 xor q1 bar, or I can simply write it q0 xnor q1. Okay, now let's see. Here you can see this q0 q1, that is 0 0, that is given to you. Let's find what is d0 d1. D0 is q0 bar, d0 that is q0 bar, so it will be 1. D1, that is what, that is xnor of q0 q1. 0 xnor 0, that will be 1. Yes or no? XNOR is 1 when both are same. So you can say 0 XNOR 0, that will be 1. So now we have D0 D1 also we have. Now let's find the next state. Now remember, these are D flip flop, and you remember the behavior of the D flip flop, that in the D flip flop, whatever is your D input, that will be your next state. Yes or no? In D flip flop, we know this behavior, that next state, that is same as D input. Do you agree? In the D flip flop, we know this. In D flip flop, the Q next, the Q next, the next state, the Q next, that is same as D. Okay, this we already know. So the same, you can just see here that D0 is 1. So this will become your next state. D1 is 1. So this will become your next state. Simple. So simple. Yes or no? So I can say that from 0 0, basically, we will go to 1 1. Okay, let me draw the state diagram here. Let me draw a state diagram. Notice here you can see in this circuit, all the D flip flop, these are basically positive edge triggered D flip flop. Okay, so let's draw the state diagram. Initially we are in q0 q1 equal to 0 0. Initially we are in this state. You can see from this state, after one clock cycle, or I can say after one rising edge, because all the D flip flop, these are positive edge triggered here. Okay, so I can say that from this state, after one clock cycle, after one clock pulse, we will go to which state? We will go to state 1 1. We will go to state 1 1. Now let's see, from state 1 1, where we will go after one clock cycle, or I can say after one rising edge, or after one clock pulse. Basically, from this 1 1, what will be the next state? Let's find. So what we will do, we will assume that this 1 1 is the present state. So now this 1 1, you assume that this is the present state. Now let's find what will be the next state from 1 1. Okay, so you can see what is D0 D1. D0 is Q0 bar, so that will be 0. And what is D1? D1 is XNOR of Q0 Q1. So you can see XNOR of 1 1, that will be 1. Now notice, these are D flip flop. In the D flip flop, the next state, that is same as the D input. Yes or no? Whatever is the D input, that will become the next state. So you can see that this Q0 next, Q1 next, that will be basically this 0 1. Simple. So it means that from 1 1, the next state is 0 1. Okay, we are going to 0 1. Now from 0 1, where are we going? Means from 0 1, what is the next state? Means after one clock cycle, after one rising edge, where we will go. So let's see. Now let's assume that this 0 1, this is the present state. Now let's assume. So you can see what will be D0 D1. D0 is Q0 bar. So this will be 1. And D1, that is XNOR of Q0 Q1. XNOR of 0 comma 1, that will be 0. And you can see, because we are dealing with D flip flop here, in the D flip flop, whatever is the D input, that will be the next state. So you can see the next states will be 1 0. So it simply means that from 0 1, the next state is 1 0. Okay, the next state is 1 0. Now let's see from 1 0, where we will go. From 1 0, this 1 0, you assume that this is the present state. So what is D0? That is Q0 bar. So that will be 0. What is D1? This is the XNOR of Q0 Q1. So 1 XNOR 0, that will be 0. So you can see that because we are dealing with D flip flop, in the D flip flop, whatever is the D input, that will be your next state, next output. So you can see this D value, this will become your next output. So you can see from 1 0, we are going to 0 0. Okay, from 1 0, from this state 1 0, you can see after one clock pulse, we will go to state 0 0. After one rising edge, or I can say after one clock pulse. That's it. So you can see this is the state diagram we got. From 0 0 you are going to 1 1. From 1 1 you are going to 0 1, then 1 0, then 0 0. Okay, this is the answer. The question was asking for state diagram. You can see the question was asking for state transition sequence or state transition diagram. So you can see that answer will be from 0 0 we are going to 1 1, then 0 1, then 1 0. Okay, yes or no? And then from 1 0 to 0 0, from 1 0 to 0 0. So for this question the answer will be option D. Okay, very simple question. I hope you understood. So I hope you are feeling more confident now. Okay, let's solve gate 1994 question. Find the contents of the flip-flop Q2, Q1, Q0 in the circuit of figure after giving 4 clock pulses to the clock terminal. Assume initially Q2, Q1, Q0 equal to 0, 0, 0. See, the question is very simple. Initially, the state is given to you Q2, Q1, Q0, that is 0, 0, 0. And after 4 clock pulses, means after 4 rising edges, because remember, all these flip flop you can see they are positive edge triggered. So I can say that after 4 clock pulses or after 4 rising edges, what will be the state? This is what the question is asking. Remember, the question is asking content of the flip flops, and I told you that content of flip flop that is same as state. So basically the question is asking what is the content of flip flops after 4 clock pulses. So that is same as the state after 4 clock pulses. Okay, because you already know content stored in the flip flop that is same as state of the flip flop, that is same as output of the flip flop. Similarly, for a circuit, content stored in these flip flops or content stored in this circuit that is same as state of this circuit. Okay, that we already know. So you can see we already know that content stored in a sequential circuit, content stored in a sequential circuit that is same as state of that circuit, state of that sequential circuit. Both are same things. Okay, content stored is the same as state. Okay, now notice one thing, that this is a synchronous sequential circuit because all the flip flops they are operated by the common clock. You can see this common clock, the same clock signal, this is input to all these three flip flops. So I can say that this observation you can make, that this is a this is a synchronous synchronous sequential circuit. Okay, very simple observation. Now one more thing, this is actually a very interesting question because here the flip flops, these are JK, D, T. We have three different flip flops we have. Okay, so basically through this question, using this question, your complete revision of JK flip flop, D flip flop, T flip flop will happen. So this is a beautiful question. You need the knowledge of JK, D, T, all the flip flops. Okay, so let's solve this question. Because this is a synchronous sequential circuit, we have already seen how to analyze the synchronous sequential circuits. What are the steps? The step number one, we will write the flip flop input equations. For each flip flop, we will write the input equation. Then the step number two, we will draw the state table. In the state table, we will write column for present state, then column for flip flop inputs, then column for next state. Then we will construct a state diagram. Okay, so these are the steps. Very simple. So let's solve this question. What is the step number one? The step number one is we will write flip flop input equations. So let's write the flip flop input equations here. Here you can see for this flip flop, what are the input equations? This J, this is equal to what? Look at this J, this input. So this J is basically same as Q0 bar. You can see this Q0 bar, that is same as J. Okay, so you can see, so J is equal to Q0 bar. Okay, and next you can see what is K. K is fixed, that is K equal to 1. This is fixed. Now let's see what is D. D is same as Q2. What is T? T is same as Q1. Okay, so we have found the flip flop input equations, correct? Very simple. Now notice one more thing here, that the question is saying that initially Q2, Q1, Q0, that is 0, 0, 0. What it means? It means that this Q2 is MSB. Yes or no? From here, you can see that this Q2, this is MSB. This Q2 is MSB here. Okay, and you can see this Q0 is LSB. This Q0 is LSB. Okay, so this is another observation. Initially, we have Q2, Q1, Q0 equal to 0, 0, 0. Okay, so you can see the step number 1 that is over. We have written flip flop input equations. Now, what is the step number 2? We will draw a state table. Okay, so let's draw the state table. In the state table, I told you that we will have present state, then section for flip flop inputs, and then next state. Okay, so you can see what is the present state, that is Q2, Q1, Q0. The question is already saying that Q2, Q1, Q0. This is how we denote the state of this circuit, and Q2 is the most significant bit. So you can see that this is the present state, Q2, Q1, Q0. This is the present state. Then what are the flip flop inputs? These are J, JK, DT. Okay, you can see JK, DT. Okay, with Q2 we have JK, with Q1 we have D, with Q0 we have T. Okay, so you can see these are the flip flop inputs, and you can see what is the next state. Q2 next, Q1 next, Q0 next. Okay, so let's see here. Now, notice this is given to you that is initially this Q2, Q1, Q0, this is 0, 0, 0. This is given to us already. You can see, assume that initially 0, 0, 0. Now, what we will do? This information is given to us. Then what we will do? First, from here, we will find this. This is the step number 1. Then what we will do? From these two, from this and from these two, we will find this. Okay, this will be our 2. So very simple point. I hope you understood. Now let's see. Here you can notice that these are the present states. This is the present state of the circuit. These are flip-flop inputs, and these are the next state. Okay, so let's see here. So you can see initially we have 0, 0, 0. And whatever we have found, the flip-flop input equations, let's write because they will be useful. So you can see these flip-flop input equations. J is equal to Q0 bar. Correct? J is equal to Q0 bar, and K is equal to 1. And you can see what is D equal to? D is Q2, T Q1. D Q2, T Q1. Okay, you can see D is Q2 and T is Q1. Simple. That's it. Okay, now let's see. You can see from 0, 0, 0, what will be JK DT? J is Q0 bar. This J, this is Q0 bar. So you can see J will be 1. K is fixed, that is 1. D, that is Q2, so that is 0. T, that is Q1, so that is 0. Okay, so now let's see. From these, we need to find the next state. What will be Q2? Q2 plus means the Q2 next. Okay, so you can notice who will decide this Q2 next. Tell me. Notice. This Q2, this is the state, this is the output of this JK flip flop. So who will decide the Q2 next? The next state of this JK flip flop will be decided by this present state Q2 and this JK. Do you agree? So remember, this Q2 next, who will decide? This Q2 and this JK. Okay, so remember, this Q2 and this JK, these will decide what will be Q2 next. Okay, so let's see. In the JK, if we have 1, 1, you already know the behavior of JK flip flop. In the JK flip flop, we have already seen that when JK is equal to 1, 1, this is the toggle combination. Means when JK equal to 1, 1, then the next state will be complement of the present state. Do you agree with me? In the JK flip flop, you can see the characteristic table, the truth table, the behavior table. You can see when JK equal to 1, 1, then this is the toggle combination. So the next state, that will be complement of the present state. So you can see here I will write 1. Simple. Now you can see. Let's find what is Q1 next. Who will decide Q1 next? Q1 and D, they will decide Q1 next. These two, they are going to decide Q1 next. So you can see in the D flip flop, whatever is the D input, that will be your next state. So you can see it will be 0. Okay, in the D flip flop, whatever is the D input, that will become your next output or next state. Simple. So simple. Now let's see. What will be Q0 next? Who will decide Q0 next? This Q0 and T. These will decide Q0 next. Okay, so let's see. These are going to decide the Q0 next. So in the T flip flop, if input T is equal to 0, then the next state will be same as the present state. So here I can say it will be 0. Simple. So basically from 0, 0, 0, the next state will be 1, 0, 0. Okay, this is the whole point, that the next state is 1, 0, 0. I hope you understood. Let me make the state diagram here. So you can see Q2, Q1, Q0. Initially, we are in the state 0, 0, 0. This is given to you, that we are in, initially we are in this state. Then after one clock pulse, or I can say that after one rising edge, because all the flip flops, these are positive edge triggered, you can easily notice. All these are positive edge triggered. Okay, so here I can say that from this state 0, 0, 0, after one clock pulse or after one clock cycle or after one rising edge, we will go to state 1, 0, 0. Okay, now let's see. From this state 1, 0, 0, where we will go? Because what the question is asking that after 4 clock cycle, what is the content of this circuit? Content of this circuit means state of this circuit. So after 4 clock cycle, what is the state of this circuit? This is what the question is asking. Okay, so let's see. Now you can see from 1, 0, 0, what will be the next state? This is what I need to find. So what I will assume that 1, 0, 0, this is the present state. Assume this 1, 0, 0 is the present state. Now let's find what is jk dt. K is fixed, that is 1. Now what is j? J is q0 bar, so it will be 1. What is d? This is q2, so that will be 1. What is t? This is q1, so it will be 0. Okay, now let's see here. Now let's see. So you can see this q2 next. Let's find who will determine q2 next. This q2 and jk. Q2, this I can say that this q2 and this jk, both of them, they will determine what is q2 next. So tell me what is q2 next here. Jk is equal to 1, 1. When jk equal to 1, 1, this jk equal to 1, 1, this is the toggle combination. So the next state, that will be complement of the present state. So you can see the next state that will be complement of the present state means it will be 0. Simple. Now let's see what is q1 next. Who will determine what is q1 next? This q1 and d, they will determine what is q1 next. Okay, so you can see in the D flip flop, whatever is the D input, that will be your next state. So you can see it will be 1. Okay, now let's see what will be this Q0 next. Who will determine Q0 and T? These two, they will determine what is Q0 next. So you can see in the T flip flop, if input T equal to 0, then the next state will be same as the present state. So you can see it will be 0. So we are going to 0, 1, 0. Correct? Okay, so I can say that from this state 1, 0, 0, the next state will be 0, 1, 0. Okay, yes or no? 0, 1, 0. Simple. So I can say we will go to 0, 1, 0 state. Now, from this 0, 1, 0, where we will go? What will be the next state from 0, 1, 0? So let's assume that this 0, 1, 0, this is the present state. This 0, 1, 0, let's assume this is the present state. So what will be the next state? Let's find. You can see what is jk dt. K is fixed, that is 1. J is q0 bar. J is q0 bar, so it will be 1. D is q2. D is q2, so it is 0. T is q1, so it is 1. Okay. Now let's see. What will be q2 next? Who will decide q2 next? Q2 and jk? Yes or no? So you can see jk equal to 1, 1. This is the toggle combination in the jk flip flop. If jk equal to 1, 1, then the next state will be complement of the present state. So you can see q2 next, that will be 1. Okay, what is q1 next? Who will determine q1 next? Q1 and d. Whatever is the d input, that will be your next state. So that will be 0. Now let's see q0 next. Who will determine q0 next? Q0 and t. In the t flip flop, if t equal to 1 in the t flip flop, if t input t equal to 1, then the next state will be complement of the present state. So you can see that next state will be 1. So you can see we are going to 101 state. Okay, you can see from 010 we are going to 101 state. Now let's see from 101 state, what will be the next state after one clock cycle. So let's see. Let's assume that this 101, this is the present state 101. Now this k, that is fixed 1. What is j? That is q0 bar. So you can see this j will be 0. Okay, because j is equal to q0 bar. Q0 is 1, so j will be 0. Now d equal to q2. D equal to q2, that will be 1. T equal to q1. T equal to q1, that will be 0. Okay. Now let's see. What will be q2 next? Q2 next, who will determine? Q2 and jk. In the jk, if you have 0, 1, then this combination, what it will do? In the jk, j is set and k is reset. That we already know. Yes or no? So you can see jk equal to 0, 1. It means it is reset combination. Jk equal to 0, 1 is the reset combination. So the next state will reset, means it will become 0. The next state will be 0. Now let's see. What is q1 plus? Who will determine? This q1 and d. And you can see in the d flip flop, whatever is the d input, that will be the next state. So it will be 1. What is q0 next? Who will determine? Q0 and t. In the t flip flop, if t equal to 0, then the next state will be same as the present state. So it will be 1. So you can see we are going to 0, 1, 1. Okay, now you are going to 0, 1, 1. Correct? Now, the question was asking that this is the initial state. So after 4 clock cycle, we will go to which state? This is the answer. You can see if you start in this state 0, 0, 0, then after 1 clock cycle, you will go to this state. After 2 clock cycle, you will be here. After 3 clock cycle, you will be here. After 4 clock cycle, you will be in state 0, 1, 1. Okay, so remember answer we have got, that is state 0, 1, 1. The question was asking find the contents of flip flops q2, q1, q0 after giving 4 clock pulses from this state. Okay, so tell me what is the answer here. You can see we have already seen that this is the initial state after 1 clock cycle, after 2 clock cycle, after 3, and after 4. So I can see after 4 clock cycle, the content will be 0, 1, 1. Okay, so you can see the answer. Let me write it here. The answer is 0, 1, 1. I hope it is clear. Okay, this question we have solved. But let's not stop. Let's complete this. Okay, let's complete this state diagram. So now you can see, now we are in the state 0, 1, 1. Where we will go from 0, 1, 1. From 0, 1, 1, where we will go? Let me do it as quickly as possible. So you can see this j, this is q0 bar, so it will be 0. K is fixed 1. D equal to q2 and T equal to q1. Okay, now let's see. You can see jk equal to 0, 1. This is the reset combination. So q2 next, that will be 0. You can see d equal to 0. So this will become the next state. And you can see t equal to 1. So the next state will be complement of the present state. So you can see the present state is 1. So the next state, that will be 0. So you can see that from 0, 1, 1, we will go to state 0, 0, 0. Okay, from 0, 1, 1, we will go to state 0, 0, 0. If you are in this state 0, 1, 1, then after 1 clock cycle or after 1 clock pulse, or I can say that after 1 rising age, we will go to the state 0, 0, 0. That's it. Now you can see we got this loop in the state diagram. I hope you understood. So remember, if you start here, then after 4 clock pulse, you will go to 0, 1, 1. And after 5 clock pulse, you will come back to 0, 0, 0. So like that. I hope you understood. Okay. So very simple question. So in this session, some gate PYQs we have done. I hope you found some confidence in the synchronous sequential circuit. Remember, some concepts we have seen in this lecture, some terminology basically, some small concepts, then some practice questions we have done, and then some gate PYQs we have done. I hope you are feeling a lot of confidence right now. And remember, in the upcoming lectures, we are going to solve all the remaining gate PYQs from all the gate branches based on synchronous sequential circuits. Once we solve 100 plus gate PYQs, then definitely you will feel so much confidence that this sequential circuit, this will become your favorite topic in the digital logic subject. And that is my target. Okay. So thank you everyone. Please share your feedback. Please let me know. Did you understand everything? Did you enjoy this session? Are you feeling confident in sequential circuit? Did you feel confident? So let me know in the comments. Thank you everyone.